Hello everyone and welcome to this Docker and Kubernetes crash course, and I am Ashok from Ashok IT. In the next 4.5 hours, we are going to understand Docker and Kubernetes from the basic level. I'm going to explain every topic in the simple way with practical examples so that anyone can easily understand. And here first we learn what is Docker, why Docker, how to set up Docker and how to create the Docker containers. Then we will move on to the Kubernetes. We'll understand what is Kubernetes, Kubernetes architecture, what is pod, what is service, and how to manage the containers by using Kubernetes orchestration platform. You don't need any prior knowledge in order to attend this session. So just to follow the session and practice the examples, then you will get the full clarity on Docker and Kubernetes concepts. Without wasting much time, let's get started with our Docker and Kubernetes learning journey. Welcome to Ashok IT. Today we are here to understand what is Docker, why Docker, and how to work with Docker. What is the importance for the Docker in the real-time projects implementation? Good. What is Docker? First of all, what is Docker? Some people will say Docker is a DevOps tool. Every DevOps engineer should know Docker. So Docker is not only for the DevOps engineers, even developers also should know what is Docker. So we can say Docker is used for containerization. It is a containerization tool. Docker is used to perform containerization for our applications. Here comes the biggest question. What is containerization? So before going to understand what is a containerization, first we need to understand our application architecture. So in simple terminology, to give the definition for the Docker, so we can say what is Docker, and Docker is a containerization software, but it's very high level terminology. What is that containerization? So before getting into containerization part, let's understand application architecture. If you take any project, you can see front end will be available for the project, back end will be available for the project, and the database also will be available for the project. So database is used to store our application data. There are so many databases available in the market like Oracle, MySQL, SQL Server, MongoDB, etc. There are so many databases available. Depends on the requirement, we will use one database for our application. Along with that, for every project, backend will be available. Backend contains business logic. So the business logic will be implemented in the backend. To implement backend of the application, there are several technologies are available. Java, .NET, Python, PHP, Node.js, like that there are so many technologies are available. By using those technologies, we can develop backend of the application. Backend contains only business logic. Then coming to the front end, user interface. Whatever you see on the browser, that is called as user interface, that is also called as front end. In order to develop front end of the application, we are going to use several front end technologies like Angular, React, or Vue.js. Like that, there are several front end technologies are available. By using those front end technologies, we are going to develop the user interface of the project. Guys, for all of you, is my voice clear? Is my screen and voice clear for everyone? Yeah, good. So a project contains 3 layers, guys. Front end will be available, back end will be available, and database will be available. So this is application architecture. So when we are talking about a project, a application contains front end. That front end, nothing but user interface, and backend will be available and database will be available. So front end is used to develop user interface. To develop the front end, there are several technologies like Angular, React, Vue.js. Like this, there are several technologies are available. To develop backend of the application, there are several technologies like Java, .NET, Python, PHP, etc. Like that, there are several technologies are available to develop backend of the application. Coming to database, for every project, database is mandatory. So like Oracle or MySQL or SQL Server, like that there are several databases are available. Now Let us take one example. Suppose I want to build one project. I want to develop one project and I want to deliver that project to the customer. Now we need to take application tech stack. We need to take the application tech stack. That means what are the technologies we are going to use to develop our application, that is called application tech stack. So here for the front end, I'm using Angular. Assume that. For the front end, I'm using Angular 13 version. And for back end, I'm using Java 17 version. And for a database, I'm using MySQL 8.5 version. MySQL 8.5 version I'm using. So this is called application tech stack. So I want to develop a project. For the project development, we are going to use Angular 13 version for the front-end development. And for Java, for back-end development, we are using Java 17 version. And for a database, we are using MySQL 8.5 version. Now fine. So in order to develop this application, we are taking these technologies. Then after, once the project development got completed, development team will be available. The development team is going to write the code, front-end code, back-end code, database queries. They will develop a project. Once they develop the project, we need to deploy this application. So developers should run this application and DevOps engineers should deploy this application in the higher environment. Okay. So now we need to understand environment setup to run our application. So what we need to do in order to run our application? In order to run our application, we need a platform. Development team completed the coding part and they have stored the code into GitHub. Now, it is the responsibility of the DevOps engineers to deploy this application in the higher environments. So in order to deploy this application, DevOps engineers should prepare an environment. So what they have to do, take one machine. So we can say it is a physical machine or virtual machine. Anything is fine. A physical or virtual. So we need to take one machine. After that, install Angular 13 version, because to run the front-end code, Angular software is required. So if you want to run your application in a computer, then you need to take one computer with OS. That can be a physical machine or that can be a virtual machine. Install Angular 13 version in that machine. Then after, install Java 17 version. Install Java 17 version and install Tomcat server. Because to run the Java application, Tomcat server is required. Install Tomcat server 9.0 version. Then after, install MySQL database server. Install MySQL DB server 8.5 version. So this is called as environment setup. We are working on a project. Our project is having front-end, back-end, database. For front-end, there are so many technologies are available. We are using Angular for the front-end development. Back-end, we can develop by using multiple technologies. We are using Java 17 version to develop the back-end of the project. There are so many databases available. For our project, we are using MySQL database, which is 8.5 version. Got my point? Good. Now here, in order to run this application, we need to prepare the environment. Environment setup is required to run our application. So how environment setup will be done? DevOps people are going to do this environment setup in order to deploy and run our application. They need to take one computer. That can be a physical computer or virtual computer. And they need to install Angular software, because to run the front-end code, Angular is required. And to run the back-end code, Java software is required. They need to install Java version. And they need to install Tomcat server 9.0. To run the Java application, the Tomcat server is required. And they need to install MySQL database server so that our application can communicate with the database. This is environment setup. That environment setup we have to do manually. DevOps engineers has to perform this environment setup manually in order to run our application. How many times they have to do this environment setup? How many times they need to deploy our application? So in the real time, we will be having multiple environments, guys. Those are called as application environments. Once the coding is completed, directly we are not going to deliver that code to the client. Our application will be tested in the multiple environments. Like we will have dev environment, we will have SIT environment, we will have UAT environment, and we will have pilot environment, and we will be having prod environment. So these are called as application environments. Okay. Dev environment, developers will use this environment for developers integration testing. Developers will use it for developers integration testing. All the developers code will be integrated at one place, like source code repository server will be available, like a GitHub or Bitbucket. In a project, there are 10 developers available. All the developers code is integrated at one place. Now, once the code is integrated, whether that code is working as expected or not, we have to test it. For that, all the developers code will be integrated and that code will be tested by the developers only. For that testing purpose, we need one environment called dev environment. What is the meaning of a dev environment? A separate platform, a separate environment. So they need to take one computer, install all the required softwares, and deploy the application. Okay. So now dev environment will be used by only developers to perform integration testing. Then similarly, SIT environment will be available. Testing team will use it for system integration testing. Developers will do developer integration testing, whereas testing team will use it for system integration testing. Again, another environment. Another environment means, again, they need to take a computer, again, install all the softwares to run the application. So environment setup to run our application is a difficulty here. Then what is UAT? Client will use it. Client side team or client. Client will use it for acceptance testing. Okay. So whatever the application we have developed, is that application working as expected or not? Client has to approve that. For that, we are going to give our application for the client as part of UAT. UAT stands for user acceptance testing. So UAT is a separate environment. Client will use this UAT environment for acceptance testing. Then pilot. Pilot is nothing but pre-production environment. Okay, pre-production environment. Before our application will be given to the client for in the production environment, our application will be tested again in the pilot environment. Then finally, once the pilot testing is completed, then we will go for the prod. Prod is nothing but live environment. So end users can access our application from the prod. End users can access our application running in prod. Prod environment will be available. Any application that we are accessing through internet, nothing but it is from the prod environment. Production environment, nothing but live environment. Production, nothing but live environment. So in the real time, once the developers development got completed, once the developers coding got completed, our application will be deployed into multiple environments for a testing purpose. So in the real time, for every project, multiple environments will be available, like dev environment, SIT environment, UAT environment, pilot environment, and prod environment. Who will use the dev environment? Dev environment will be used by developers to perform integration testing. What is the meaning of integration testing? So multiple developers are working, they will work on different functionalities. Once the code is integrated, all the developers code working as expected or not, that verification process is called integration testing. Okay. Once the developers integration testing got completed, then our application will be deployed into SIT environment. So testing team will use it for system integration testing. SIT will be done for our application. Testers will be available. The testers are going to test our application. For the testers, separate environment will be available. UAT. Client will use it for user acceptance testing. UAT stands for user acceptance testing. Before going to deliver the project to the client, we will give for the trial run. Client will check, is everything working as expected or not? Once UAT completed, our project will go to pilot. Pilot, nothing but pre-production environment. Before deploying our application to the live environment, we are going to deploy the application in the pilot environment. Okay. And the next one is prod. Prod is nothing but live environment. End users can access our application running in the prod environment. Now, if you see, Now, if you see here, there are multiple environments available. There are multiple environments are available. Now, in order to deploy our application into all these environments, like here, dev environment is available and sit environment is available, UAT environment is available, pilot environment and production environment, like that. Multiple environments are available. Can you guys tell me what is the environment? Now, so here we need to install Angular, okay? Then install Java, and Angular also very specific, 13 version should be installed. Install Java 17 version, then install Tomcat 9.0, install MySQL 8.5. So this is called environment setup in order to run our application. This is environment setup to run our application. Now this is called as dev environment. So this is one machine. In that machine, we are installing all the required software. Then we are going to run our application. Okay. So the same thing is required when you go for SIT environment. So again, we need to take one more machine. In that machine, we need to install all the softwares. So that is called as SIT environment. Again, we need to take one more machine for the UAT, and we need to install all the softwares in order to run our application in the UAT. Same thing we need to do for the pilot. So before giving the project to the customer, before delivering the project to the production, we are going to do the pilot testing. Pre-production testing will happen. Once the testing is completed in all the environments, then finally we are going to take one more machine and we are going to install all the required softwares. That is called as production environment. So that is called as production environment. So in the real time, our application will have multiple environments for testing. Our application will have multiple environments for testing. Okay. So environment, nothing but it is a platform where we can run our application. Guys, now, if you observe, is there any challenge in our application deployment process in the real time? Is there any challenge? Is there any challenge to run our application in the multiple environments like this? Is there any challenge or there is no challenge? Can you see any challenge here or there is no challenge here? What is the challenge here? What is the challenge that you have observed here? Can you tell me? That will give the answer for what is Docker. What is the challenge here? We have to install the required softwares in all the machines wherever we want to run our application. Okay. So today I am having only 5 environments. In the 5 systems, I have to set up all the required softwares. And the most important thing is software version conflicts. Software version conflicts. So in the dev environment, already Java 11 version is available. But for our application, Java 17 version is required. There is a chance of getting version conflicts when we are running our application in multiple systems for testing purpose. We should be very careful when we are installing the software to run our application. Okay. And so to set up this platform, set up this environment, manually they are going to install all the softwares. Humans are going to do this setup. There is a chance of doing the mistake. Now, so here the challenges, version conflicts can occur. So whatever the machine I am taking in order to run my application, in that machine already Java 11 is available. Okay. But for our application, Java 17 is required. Okay. Version conflicts can occur. Okay. So setting up environment setup is time-taking process and it is error-prone. That means a human is going to do this environment setup in order to run our application. A human is going to do all this setup. So there is a chance of getting errors. So we can do some mistakes also. And repeated work. Setting up the multiple environments is a repeated work. And for example, tomorrow our application is upgraded from Java 17 to Java 21, Angular 13 to Angular 14. We got some new features in the Angular and Java new versions. I want to migrate my application to Angular 15, and I want to migrate my application to Java 21. Then what I need to do? We have done all the environment setup in order to run our application. But after 3 months, we got the upgradation request. We need to upgrade our application front end to Angular 15 or Angular 14, and Java version we need to upgrade from 17 to Java 21. Then is it easy? Guys, is it easy? Come on. You need to uninstall all the softwares available in all the environments. And again, you need to install new version of the software, and you need to run your application. So that maintenance cost will be high. So today I have only 5 environments. For example, so we are working on very large scale application. We have 10 environments to test our application. Then can you imagine the scenario? Now, can you imagine the scenario? If you want to test your application in the 10 environments, 10 computers you have to take. In 10 computers, you have to set up all the softwares to run your application. Okay. And if any version upgrade is required, then the things will become very complex. You need to uninstall Angular and Java from all the systems, and again install the latest version of Angular and Java, then deploy the application, then test that application is working as expected or not. So here, is there any guarantee the application which is working in one system will execute in all the systems in the same way? Is there any guarantee? The code which is working in one computer in the dev environment, can you guarantee that code will work in all the environments? No. It depends on the softwares we have installed. It depends on the platform. It depends on the versions of the softwares we have installed. Then what issues will occur, in the real time? Developers will say that the code is working in my system properly. Testers will say that the code is not working in our system. Then in the dev environment, whatever the code is working as expected, the same code is not working in the SIT environment. Then the fighting will happen between the developers and testers. Developers will blame the testers. Testers will blame the developers. So these are called environmental issues. These are very common in the real time. The code which is working in the dev environment, the same code is not working in the SIT environment. The reason? Environment issue, not the code issue. Sometimes code issues also will be available. We have to accept that. Most of the times when we are going for the environment, we should be very careful about the environment setup in order to run our application. So this is the biggest challenge. This is the biggest challenge in the real time to test our application. Are you guys able to understand? So we are trying to understand that an application will be available. Application contains 3 layers. Front end will be available, back end will be available, and database will be available. So we need to use one database, one back end technology, one front end technology to develop the application. So here I'm taking an example. My project front end is developed by using Angular, back end is developed by using Java, and MySQL database we are using. So that is called tech stack of the application. Here I have decided the application tech stack. Angular 13 version I'm using for the front end. Java 17 version I'm using for the back end. MySQL 8.5 version I'm using for the database. Okay. And in order to run this application, I need a Tomcat server. The Tomcat server I'm using 9.0 version. To run the Java web application, Tomcat server is required. I'm using Tomcat 9.0. Okay, guys. Then once the application development is completed in the developer systems, all the code is integrated. Now, as a DevOps engineer, we need to integrate that code and we need to deploy that code into multiple environments. First of all, what is environment? Environment, nothing but a platform where we can run our application, right? In the companies, multiple environments will be available in order to run our application. How they will do environment setup? So they will take one machine that can be a physical machine or a virtual machine. Then they will install required softwares. For our application, front end is Angular 13 version, back end Java 17 version, Tomcat Server 9.0 version, database 8.5 version. These softwares should be installed in the machine in order to run our code. These are called as dependencies of our application. Okay, so in my application code is available. In order to run that code, Angular 13 version should be installed in the computer. Java 17 version should be installed in the computer. Tomcat Server 9.0 version should be installed. MySQL database server 8.5 version should be installed. Can we call these things as dependencies of our application? Can we call them as dependencies of our application? Yes, we can call them as dependencies of our application. So the deployment team, the operations team should set up all these dependencies in the system to run the application. How many places they need to set up these dependencies? That depends on project to project. Okay, so in the real time, for every project, multiple environments will be available, like dev environment, sit environment, UAT environment, pilot environment, and prod environment. Okay, so dev environment, sit environment, UAT, pilot, and prod. Got my point? Here, who will use this dev environment? Dev environment will be used by developers. Developers will use it for integration testing. All the developers' code should be tested at one place. For that, they will use this dev environment. Testers should test our application. For that, we will have a SIT environment, that is system integration testing. UAT, client will use it for user acceptance testing. Okay, pilot, pre-production environment. Before deploying our project to the production, we will use it. We will test it in the pilot environment. We'll test it in the pilot environment. Prod is a live environment. End users can access our application running in the production environment. Now, environment setup is a challenging task, guys. Challenges in deployment process. Can you tell me what are the challenges in the application deployment process? So once the code is completed, directly, we are not going to deliver that code to the client. Our application should be tested in the multiple environments. Okay, challenges in the deployment process. The first thing is environments setup. Environments setup is the first challenge. Okay, and setting up required dependencies. Dependencies nothing but softwares, guys. So the front-end software, back-end software, database software, setting up required dependency is one of the challenging tasks. So setting up multiple environments setup. It's not one environment. In the real time, multiple environments will be available. We have to set up those environments, and we have to set up required dependencies. Okay, version conflicts. Our application requires Java 17 version, but by mistake they installed Java 11 version. The code which is implemented with Java 17 version will not work with the Java 11 version. Such kind of version conflicts will occur. And the second problem is environment maintenance. Environment maintenance is another biggest problem. Okay, environment maintenance is another biggest problem when you go for this multiple environments. Are you guys getting my point? So what are the challenges in the deployment process? Multiple environments setup and setting up the required dependencies. That means what are the softwares that are required to run our application, setting up all required softwares in all machines. So I have 10 environments. Okay, in the 10 environments, I have to set up all these softwares. 10 environments are available. I have to set up this 10 environments. Got, guys? Now, version conflicts. My application requires Java 17 version, but by mistake, they have installed Java 11 version. Then my application cannot work. Are you guys getting my point? Okay, tomorrow if I want to change the version, then what is the issue? Then what is the issue, guys? If I want to change the version, then what is the issue? Need to uninstall and install. Environment maintenance. Okay. Environmental issues will occur. The code which is working may not work in the code which is working in one environment may not work in all the environments. The code which is working in the one environment may not work in other environment. Then teams will try to blame others. Teams will try to blame others. Got my point? Developers are saying that the code is working in the dev environment properly. We have done very good coding. The code is working in the dev environment properly. But testers are saying that the code is not working in the SIT environment. The reason? In the SIT environment, by mistake, they have installed Java 11 version. Actually, our application requires Java 17 version, but some mistake happened in the SIT environment. Java 11 version is installed. Because of that Java 11 version, the code is working. The code is not working in the SIT environment. Then the fight will happen between the developers and testers. Are you clear? Are you guys clear with my point? Are you guys clear with my point? People who are watching from YouTube live, give me a like for this video and give me a comment. People who are watching from YouTube live, give me a like for this video, smash that like button and give me a comment whether you are able to understand or not. Perfect. So with this, we understood what are the challenges that we face in the industry to run our application. Okay, what are the challenges we are facing in the industry to run the application? Now, to overcome all these challenges in the application deployment process, we are going to use Docker. To overcome all these challenges in the industry, we are going to use Docker. Okay, so now we need to understand what is Docker and how Docker is going to solve these problems. First of all, before getting into the solution, are you clear with the problem that industry is facing? Are you clear with the problem that industry is facing? Yes, the problem is environment maintenance. Running our application in multiple systems is very difficult. Okay, running our application in the multiple environments is challenging. Running our application in the multiple environments is challenging. Environment setup is going to take time. Environment setup is going to take time. So to overcome this problem, we are going to use a concept called Docker. Okay, so now when you go for the Docker, so let me tell you, when you go for the Docker, you no need to install all these softwares. When you go for the Docker, you no need to install all the softwares. Without bothering about the required softwares, you can run your application in any computer. Okay, you want to run your application in the 10 computers. Happily, you can run your application in the 10 computers also without bothering about the software's installation. What are the softwares are required? What are the dependencies? Instead of calling them as softwares, we will call them as dependencies. In order to run my application, Angular dependency, Java dependency, Tomcat dependency, MySQL database dependency. Instead of we are setting up all the dependencies to run our application, Docker will take care of required dependencies to run our application. If I use Docker, I can run my application in any computer without bothering about the dependencies. So you just need to run your application. Docker will take care of the setup required for the application execution. So if we don't use Docker, you need to set up all the softwares to run the application in the computer. In any computer, if you want to run the application, you need to set up all the dependencies. But when you go for Docker, Docker is going to take care of everything that is required to run our application. Docker is going to take care of everything that is required to run our application. Are you guys able to follow me? Are you guys able to follow me? What is Docker? It is free. It is free and open source software. Docker is free and open source software. It is used for containerization. It is used for containerization. Okay, so Docker is called as a containerization software. Guys, don't get confused. Kubernetes, we are not discussing today. We'll conduct a workshop in the upcoming weekends for the Kubernetes. Kubernetes is called orchestration platform. Docker is called as containerization platform. So we are using Docker for the containerization. We are using Docker for containerization. What is the meaning of containerization? Containerization means package our application code plus required dependencies as single unit for execution. That is called containerization. So now it's very important. We understood the problem. Now we are going for the solution. So the solution is Docker. So the environmental issues will be available. Managing all these environments, setting up the required softwares in all the environments is very difficult for the operations team in the real time. So then how can we avoid this problem? How can we avoid this problem? In order to avoid this problem, we are going to use Docker. Okay, what is a Docker? So Docker is a free and open source software. Why we are going to use Docker? Docker is used for containerization. Docker is used for containerization. What is the meaning of containerization? Containerization means package our application code plus required dependencies as a single unit for the execution. So what is the meaning of that? So here, let's understand. My code is available. My application code is available. This is my application code done by the developers. In order to run this application, I need some dependencies. What are the dependencies are required? I need Angular 13 version, and I need Java 17 version, and I need Tomcat 9.0 version, and I need MySQL 8.5. Okay, these all are called as dependencies. So this is my application code and these are my application dependencies. So what we can do by using Docker? So by using Docker, we are going to package application code plus application dependencies as single unit. We are going to package application code plus application dependencies as a single unit. That single unit is called as a Docker image. That single unit is called as a Docker image. So whatever the application code is available, what are the dependencies that are available to run our application, we are going to package application code plus application dependencies as a single unit. That single unit is called as a Docker image. Once the Docker image is created for the application, we can run our application in any computer without bothering about the dependencies. Now, if I want to run my application into one environment called a dev environment. Now I want to run my application in the dev environment. So for the dev environment, do I need to set up any softwares, or simply I will take the Docker image and I will run the Docker image? Do I need to install the softwares, or I don't need to install the softwares, guys? Do I need to install the softwares, or I don't need to install the softwares? I don't need to install the softwares. Why I don't need to install the softwares? Because the software's installation will be taken care by Docker. The software's installation will be taken care by Docker. Okay. So now, this concept is called as containerization concept, guys. This concept is called as containerization concept. So what is the meaning of containerization? Containerization nothing but package our application and application dependencies, application code plus application dependencies. We are going to package as single unit. We are going to package as single unit for the execution. Application code plus application dependencies will package as a single unit, that is called Docker image. Once the Docker image is created, you can take the Docker image, you can run in any computer. So here I am having a dev environment. So when I take the Docker image, when I run the Docker image, here it is going to create a Docker container. So when I run the Docker image, a Docker container will be created. Inside the Docker container, our application will execute. To execute our application, what are the dependencies are required? Those dependencies will be taken care by Docker. That means we can run our application in any platform. We can run our application in any platform without bothering about the required dependencies. Now, I got a requirement that I want to run my application in the SIT environment. So as a DevOps engineer, what I will do to run the application in the SIT environment? Simply, I'm going to take one machine. In that machine, I'm going to take the Docker image and I will run the Docker image. When I run the Docker image, then what will happen? When I run the Docker image, Docker container will be created. That's it. What about the softwares? Softwares will be taken care by Docker only. So if you want to run your application in the multiple environments, what you need to do? You just need to take the Docker image and you run the Docker image. You just take the Docker image and you run the Docker image. When you run the Docker image, it is going to create Docker container. So Docker container will execute our application. This is our UAT environment. So similarly, I want to run my application in the pilot environment as well as in the production environment. Then what I will do? So I will take a computer for the pilot environment, and for the prod environment, I will take a computer. So here what we need to do? Just you take the Docker image and you run the Docker image. You take the Docker image and you run the Docker image. So when you run the Docker image, then it is going to create a Docker container. Okay. So the Docker container will be created. Inside the Docker container, our application will be executed. So this is my pilot environment. And this is my prod environment. Now, the application deployment process got simplified or not? The application deployment process got simplified or not? Come on, guys. The application deployment process got simplified or not? So earlier, we are responsible to install everything that is required to run our application. Now, we are not responsible to install the required software. Who is going to take care of the software installation? Docker is going to take care of the software installation. Now, so here, the code which is executing in one environment, confidently can I say that that code will execute in the other environments also? The code which is executing in one environment, can we say that that code will execute in the other environments also? Yes, because who is taking care of the software installation? Who is taking care of the software installation? Are we taking care of the software installation, or the Docker is going to take care of the software installation? Docker is going to take care of the software installation. Earlier, we are responsible to take care of the software installation. Now Docker is responsible to take care of the software installation. That means, so we can simplify the application deployment process in the multiple environments. So this concept is called as containerization. So Docker is a free and open source software. Docker is used for containerization. What is the meaning of containerization? Containerization means package our application code and required dependencies as a single unit for the execution. Okay. So here, when it comes to the Docker, so we are responsible to create the Docker image. Once the Docker image is created, we can run that Docker image in any computer. Once the Docker image is created, we can run the Docker image in any computer without bothering about required softwares. Okay, now my application should be deployed into 20 environments. What I need to do? My application should be deployed into 20 environments, guys. What should I do? To deploy my application into 20 environments, what I should do? Do I need to install the softwares in all the 20 computers? Or I just need to take the Docker image and execute the Docker image? Do I need to install the required softwares in all the 20 computers, or just to take the Docker image and run the Docker image? Come on, guys. Just to take the Docker image and run the Docker image. So whenever you run the Docker image, Docker container will be created. What the Docker container will do? Docker container will run our application with required dependencies. So our application deployment process simplified with the Docker. So now you need to understand life without Docker and life with Docker. You need to understand life without Docker and life with Docker. What is our life without Docker as a software engineer? Guys, what is our life as a software engineer if there is no Docker? If there is no Docker, then what is our life? Life without Docker for the software engineer. We will end up with a lot of environmental issues. We will end up with a lot of environmental issues. So if we have Docker, happily we can deploy our application in any computer without bothering about required dependencies. When I say dependencies, here the softwares that are required to run our application. We can run our application in any environment without bothering about the required dependencies. Are you clear? Now we need to understand the Docker architecture. Sir, how Docker will know what softwares are required to run our application? Okay. And if I want to change a version, suppose now Java 17 is available. Now I want to upgrade my project to Java 21. I want to upgrade my project from Angular 13 to Angular 14. Okay. How the version updates can be done by using Docker, and how Docker will understand what are the dependencies that are required for our application. So we need to understand Docker architecture. Okay. Once we understand the Docker architecture, then I will go for a Docker setup in our machine and I will show you practical examples on the Docker. Then definitely you will enjoy with the Docker workshop today. I'm not going to waste your weekend, guys. So Sunday, it's very valuable for the working people. So I'm not going to waste your time. So I will give you the very, very, very valuable content as part of today's workshop. Definitely you will feel happy for joining today's workshop. The 2 hours of time that you are going to spend with me today, it's very, very valuable for you. Got my point? So I respect your time. Yeah, I'm not going to waste that. So the only thing is, so give me some time. So definitely I will make this workshop beautiful. I hope you understood the last 1 hour, whatever we spent. So it's useful. If you are feeling that you are learning something, then that's good. You can stay for another 1 hour with me to understand. If you feel the last 1 hour, almost 1 hour completed, if you feel the last 1 hour is useful, then the next 1 hour is better than the last 1 hour, because practicals we are going to do. People watching from YouTube, almost 100 people are watching, but no likes for the video. So if you give the likes, I will get more encouragement to do more workshops like this. People watching from YouTube, so please like this video and give me a comment. So please give encouragement. If you give the likes, then I will understand that you are also enjoying this class. All good, guys. So now let's understand Docker architecture. So Docker, technically, we need to understand how Docker is going to work, what is the Docker terminology, and how to Dockerize our applications. Got it? So Docker is a free and open source software that is used for containerization. You got the clarity? What is the containerization? Containerization means package our application code plus required dependencies as a single unit for execution. So if we use a Docker in the project, we can run our application in any machine without bothering about the softwares. Okay. If we use Docker, in our project, then we can run our project in any system without bothering about underlying softwares. Okay, what softwares are available in that? Which version of the software is available? Which OS is available? Okay, we no need to bother about anything. You just take the Docker image and you run your application in any computer. Docker is going to take care of all the required setup, right? Docker is free and open source. It is used for containerization. Containerization means package our application code plus required dependencies as single unit for execution. That single unit is called as a Docker image. Okay. Once the Docker image is created for our application, we can run that Docker image in any system. By using the Docker image, we can run our application in any system without bothering about underlying softwares. Okay, good. So Docker architecture, guys. Let's understand Docker architecture. Good. Let's understand Docker architecture. So when we are talking about the Docker architecture, first we need to understand Dockerfile. Then we need to understand Docker image. Then Docker registry. Then Docker container. Okay. To understand the working process of the Docker, so we need to discuss about these four concepts. First one is Dockerfile. Second one is Docker image. Third one is Docker registry. And fourth one is Docker container. Now, so see here, when we want to Dockerize any application, here our application code will be available. Okay, application code will be available. Developers are going to write the code required for the application. Application code will be available. So this application code we can't execute in any computer because for every application some technical stack dependencies will be available. So this application front-end technology, back-end technology, database server. So if those dependencies are available, then only we can run our application. Now, what are the dependencies to run this application? Those dependencies we are going to specify inside one file that is called as Dockerfile. So what is this Dockerfile? Dockerfile is used to specify the required dependencies to run our application. We are saying that Docker is used for containerization. By using Docker, we can run our application in any machine without bothering about the required softwares, right? How Docker will know what softwares are required for my application? That's where Dockerfile comes into picture. So Dockerfile is used to specify the instructions for the Docker. What dependencies are required? I want a Linux machine to run my application. In the Linux machine, I want Java 17 version. I want MySQL database 8.5. I want Tomcat 9.0. I want Angular 13. So those are the dependencies that are required for our application. What dependencies are required to run our application? Those dependencies information we are going to provide to the Docker by using Dockerfile. We are going to provide that information to the Docker by using Dockerfile. Once the Dockerfile is available, by using the Dockerfile, we are going to create Docker image. Once the Dockerfile is ready, so in some projects, developers will write the Dockerfile. In some projects, DevOps engineers are going to write the Dockerfile. But in my point of view, both the developers and the DevOps people also should know Dockerfile creation. How to write the Dockerfile, how to specify what instructions that are required to write the Dockerfile. Okay, so Dockerfile is very, very important when we are working with the Docker, guys. Without a Dockerfile, we can't use this Docker. Got my point? Dockerfile is used to specify instructions required for our application. Okay, by using the Dockerfile, we are going to build Docker image. Once the Dockerfile is available, we need to create the Dockerfile. I will tell you how to write that also. We are going to write a Dockerfile. Once we write the Docker file, by using the Docker file, we are going to create a Docker image. Our application code and required dependencies. Where is our application code? So my Java application is available, that is packaged as a jar file or war file. So where is that code? Where is the application code available? And to run that application code, what dependencies are required, we are going to mention in the Docker file. Once the Docker file is ready, by using the Docker file, we are going to build Docker image. We are going to build the Docker image. Once the Docker image is created, that a Docker image we can store into Docker Hub, guys. That is called a Docker registry. So whatever the Docker image I have created, I want to use this Docker image in future. I want to use this Docker image. I want to execute this Docker image in multiple systems. So for that, what we will do, we can store the Docker image into Docker Hub. This is called push operation. So this is called as a push operation. Whatever the Docker image is created, we will push that Docker image into Docker Hub. So Docker Hub is called as a Docker registry. Some people will use Docker Hub to store the Docker images. Some people will use JFrog repositories, Nexus repositories, AWS ECR, Elastic Container Registries. There are multiple places where we can store our Docker images for future purpose. We can store the Docker image into Docker Hub. Docker Hub is called as a Docker registry where we can store the Docker images. Today I have created a Docker image. I want to use that image in the future. I want to use that image in multiple systems. So that's why we are going to store the Docker image into Docker Hub. So it's not mandatory that we should use only Docker Hub. What are the alternatives available for the Docker Hub? You can use Nexus repository. You can use JFrog repository. You can use AWS ECR also to store the Docker images. You can store the Docker image into Nexus repository. You can store into JFrog repository. You can store into AWS ECR, or you can store into Docker Hub. So in this workshop, I will show you how to store Docker image into Docker Hub, guys. So what is a Docker Hub? It is a registry where we can store our images. Okay. So once the Docker image is created and stored in the Docker Hub, so this image, whatever we are storing in the Docker Hub, right? We can make it as a public image or private image. If it is a public image, anybody can take the image, they can run our application. Now, our application code and application dependencies will be packaged as a single unit for execution. That single unit is called as a Docker image. Are you getting my point? What is a Docker file? Docker file contains a set of instructions to specify what dependencies are required to execute our application. Docker file contains a set of instructions to Dockerize our application. So basically, we'll specify what dependencies that are required to run our application. So Docker file is basically used to specify what dependencies that are required to run our application. So we are understanding Docker architecture. Are you guys clear as of now? Are you guys clear as of now? What is a Docker file? What is the Docker image? And what is Docker Hub? Our application code will be available. To run that code, some dependencies are required. What dependencies are required, we will specify in the Docker file. By using the Docker file, we are going to create a Docker image. Docker image contains code plus dependencies. Dependencies nothing but software. Once the Docker image got created, we can store the Docker image into Docker Hub. Docker Hub is called Docker registry, where we can store our Docker images. What are the alternatives? What are the alternatives for the Docker Hub, guys? Can you tell me? What are the alternatives for the Docker Hub? Can anyone tell me? Instead of storing Docker images in the Docker Hub, what are the alternatives available for that? What are the alternatives available for that? What are the alternatives available for that? Not GitHub. Docker image we can't store in the GitHub. GitHub is used to store the project code. GitHub is used to store the project source code, but not Docker images. Okay. We have Nexus repository. We have JFrog repositories. Nexus repository available, JFrog repository is available, and AWS ECR is available to store the images. Got it. Now, once this Docker image got created, we can pull the Docker image and we can run the Docker image. You can run the Docker image in multiple computers. Okay. So this is computer 1 where I can run my Docker image. So like this, once the Docker image got created, you can take the Docker image and you can run the Docker image in multiple systems. You can pull the image and you can run the image in any system. So whenever you run the Docker image, it is going to create. Whenever you run the Docker image, it is going to create Docker container. Whenever you run the Docker image, it is going to create a Docker container. Now this process is called run. Run the Docker image. So in which computer you want to execute your application? In that computer, you pull the Docker image. That means you pull the Docker image and you run the Docker image. Okay. So in whichever the computer you want to run your application, so you just need to pull the Docker image and you need to run the Docker image. So when you run the Docker image, what will happen? When you run the Docker image, it is going to create a Docker container. When you run the Docker image, it is going to create a Docker container. So what is the meaning of Docker container? Docker container is going to run our application. Okay. So code and dependencies are available, right? So those things are going to run. So once the image is created, we can run multiple containers. Once the Docker image is created, we can create multiple containers and we can run our application. So I have some dev environment. Okay. And I'm having some sit environment. Dev environment is available and I'm having sit environment. My dev environment and my sit environment is available. I can take this Docker image and I can run this Docker image. So wherever I want, I can run my Docker image. Dev environment and sit environment. Then next one, similarly, UAT environment or pilot or prod. Wherever you want to run your application, you just need to take the Docker image and you need to run the Docker image. This is called as Docker architecture. This is called Docker architecture. Are you guys clear with the Docker architecture? What is a Dockerfile? Dockerfile is used to specify instructions to Dockerize our application. So where is the code? What dependencies are required? That we are going to specify. Now tomorrow, when I want to change any Java version or Angular version, do I need to change everywhere or I just need to change in the Dockerfile? I want to change from Java 17 to Java 21. Where I need to change that, guys? Where I need to change that? I want to change the Java version. Where I need to change that? Do I need to change in all the systems? Do I need to change that in all the systems? Not required, right? I will change in the Dockerfile and I will create the Docker image. So whenever code changed and whenever your version changed, you need to recreate the Docker image and you need to rerun the Docker image. That's it. You need to recreate the Docker image. Suppose I specified that I want Java 17. Now today I want Java 21. Then I will change my Docker file. I will change the instruction in the Docker file. I will rebuild my Docker image. Then I will rerun my Docker image. When I run my Docker image, Docker container will be created. So where our application code and application dependencies will be available, guys? Where our application code and application dependencies will be available? Application code and dependencies will be packaged as a single unit. What is that single unit is called? What is that single unit is called? Application dependencies and application packages will be available. Application code and dependencies will be available as a single unit. What is that single unit is called? What is that single unit is called? That single unit is called as Docker image. Docker image. To create the Docker image, what is required? To create the Docker image, what is required? To create the Docker image, what is required? To create the Docker image, we need a Docker file. And where we can store the Docker images? Where we can store the Docker images? Docker images we can store in the Docker registry. We can use a Docker Hub to store our Docker images. Okay. And once the Docker image is available, you can take that image and you can run that image in any system. When you run the Docker image, Docker container will be created. When you run the Docker image, Docker container will be created. Okay. So inside the Docker container, our application is going to execute. Inside the Docker container, our application is going to execute. Now, the only thing that you need to do is, in order to run Docker image in any system, we need to install Docker software. Install Docker. Okay. So if you want to run the Docker image, you need to install the Docker software in any machine. So now I want to run my Docker image in the dev environment. So to run the Docker image, you need to install the Docker software, then you can run the image. Now I have 30 environments for my project. So in the 30 environments, I want to run my application. What I need to do? Just install the Docker, then pull the Docker image, download the Docker image, and run the Docker image. That's it. That's it. So tomorrow, if I want to change some code, if I want to change some dependencies, I will edit my Docker file. I will recreate the Docker image. Then I will rerun the Docker image. When I run the Docker image, Docker container will be created. Guys, now I have a question. Once I create the Docker image, once I created the Docker image, using that image, can I run my application in multiple computers? Using the Docker image, can I run my application in multiple computers? Yes, you can take that image and you can run that image. But what is required to run the Docker? What is required to run the Docker image in your system? What is required to run the Docker image in your system? Docker software. You just need to install the Docker software, then you can run the Docker image. When you run the Docker image, what will happen? Docker container will be created. What is Docker container? Inside the Docker container, our application is going to execute. Now, if you see the official logo of the Docker, it is a ship symbol with boxes. Why they have given ship with boxes? These boxes are called as containers. Easily we can transfer our containers from one place to another place. That means Docker images, Docker containers are easily shippable. Symbolically, they are representing in the logo. This is the logo of the Docker. So the Docker logo is a ship with containers. So that means easily we can ship our containers. Easily we can run our containers in any machine. Easily we can transfer them. So Docker is platform independent. You can run the Docker image in the Windows machine. You can run the Docker image in the Linux machine also. Docker containers we can execute in the Windows as well as in the Linux also. There is no restriction. There is no restriction. Docker is platform independent. Why it is a ship with boxes? The logo, ship with boxes, easily transferable. Easily transferable. Good. So we understood Docker architecture. What is a Docker file? It contains a set of instructions to Dockerize our application. It contains a set of instructions to build a Docker image. Where is the code? What are the dependencies? Where is the code? What are the dependencies required to run that code? We are going to specify by using Dockerfile. It contains a set of instructions to build the Docker image. And next one is Docker image. It is a package. It is a package which contains code plus dependencies. So what is the code and what are the dependencies that are required will be part of Docker image. To create the Docker image, Dockerfile is required. Dockerfile contains a set of instructions to build the Docker image. Docker image is a package which contains code plus dependencies. Docker registry. It is a place where we can store our Docker images. Docker Hub or Docker registry. It is a place where we can store our Docker images. For example, Docker Hub is a registry where we can store Docker images. Docker container. Okay. When we run the Docker image, then Docker container will be created. When we run the Docker image, then Docker container will be created. Our application will execute inside Docker container. Our application will execute inside Docker container. Okay, guys. So this is about Docker architecture. Guys, Docker internally uses virtualization, guys. Docker internally uses virtualization. Sir, what is that Docker virtualization? Now, here my Docker image is available. So assume that this is my Docker image. When we run the Docker image, what is going to happen? That is very important to understand. Okay? So Docker containers will use virtualization concept. What is the meaning of that virtualization? So here I have a computer. So assume that this is my machine. This is my machine. It can be a Windows machine or it can be a Linux machine. In my machine, I'm having host OS. Okay, this is my Windows. I'm using Windows in my laptop. Okay, so Windows OS is my main operating system. This is my host operating system. I have a computer. To use a computer, operating system is mandatory. Okay, so this Docker image is available in the Docker Hub. Assume that. So this is our Docker Hub. Inside the Docker Hub, Docker image is available. That is Java application Docker image. Now, by using this Docker image, I want to run my application. Application code plus application dependencies are available in the Docker image. The Docker image is stored in the Docker Hub. Now, I have my computer, my laptop is there. In my laptop, I need to run this Docker image. Okay, so in my computer, one operating system is available. That operating system is called host operating system. So in this host operating system, to run the Docker image, what we need to do? We need to install Docker engine. So in order to run the Docker images, first you need to install Docker engine. So Docker engine is nothing but Docker software. In order to run a Docker image in our system, you need to install Docker engine. Once we install the Docker engine, then we can pull the Docker image and we can run the Docker image. Pull means download, run means execute. Okay, pull means downloading the Docker image. Once the Docker image is downloaded to our system, then we can run the Docker image. When we run the Docker image, then Docker container will be created. Whenever we run the image, Docker container will be created. Let me call it as a C1, container 1. When I run the same image again, or a different image, okay, then another container will be created. This is called container 2. When I run the one more image, then what will happen? Another container will be created. Like this, in one machine, can I run multiple containers? In one machine, can I run multiple containers, guys? Yes, that is possible. So same image you can run multiple times so that 3 containers will be created, or you can run 3 different images, then 3 different containers will be created. Okay, so what is this container? This container is a Linux virtual machine. Okay, so our application will run in the different machine. It is independent from our host operating system. So my machine is available. My machine is having Windows operating system. In my machine, no Java, no Angular, no Tomcat, no MySQL database. But still, I can run the application as a Docker image. Inside the Docker image, code is available, required dependencies are available. What I will do, I want to run this Docker image in my system. Then I'm going to install Docker software in my system. Only Docker I will install, that's it. I will not install Java, I will not install Python, I will not install Tomcat, database, Angular, nothing. So my machine is just a machine with only operating system. In this machine, I will install the Docker software. Okay. Once the Docker software is installed in my system, then I can pull the Docker image. Pulling the Docker image, nothing but downloading the Docker image. Okay. So I can, once the Docker is installed in my system, I can create the image in the same system, or I can pull the images which are already available. I can pull the Docker image and I can run the Docker image. When I run the Docker image, what will happen? It will spin up a virtual machine in our operating system. That is called virtualization. Docker internally uses virtualization concept. So every container is a Linux machine, guys. Every Docker container that you are creating is a Linux virtual machine, where the required softwares will be available. So in our machine, one container will create. Container is one virtual machine. Inside that container machine, we can see that container machine. Practically, I will show you that also. So one virtual machine will be created. Inside that virtual machine, our code will be copied, the softwares will be installed, and our application will be executed. Okay. So in our machine, container will be created. Container is a virtual machine. Are you guys getting my point? Are you guys getting my point? How the Docker is going to manage the softwares? And what is a container? So in the layman terminology, container means one virtual box. You can say one virtual machine. If I run the image for 3 times, then what will happen? 3 containers will be created. So 3 containers means 3 virtual machines will be created on the fly. When you delete the container, that virtual machine will be deleted. When you delete the container, that virtual machine will be deleted. Okay. So can I say Docker is containerization software based on the virtualization concept? Come on, guys. Can I say Docker is a containerization software working based on the virtualization? Yes. What is the meaning of virtualization? What is the meaning of virtualization? Running one machine in another machine. Running one operating system in the another operating system is called as a virtualization. Docker will internally use that virtualization to create the containers. Container means what? It is a box. Okay. So inside that virtual machine, what will be available? What softwares will be available in the virtual machine? Guys, what softwares will be available inside the virtual machine? The required softwares to run our application. Okay. The virtual machine contains the required softwares to run our application. How this virtual machine will know what softwares are required? They are already mentioned as part of image. How that image is created? That image is created by using Dockerfile. What will be there in the Dockerfile? Set of instructions to build the Docker image. You got it? You got it? What is a container? Come on. With one image, we can create any number of containers. There is no limit. With one image, we can create any number of containers. With one image, we can create any number of containers. Container means virtual box. Container means virtual box. Got it? So containers are created based on virtualization. Containers created based on virtualization. So in one machine, we are going to run other machine. Okay. The host machine, virtual machine, both are independent. So you don't need to install any software in the host machine because Docker will take care of the softwares in the virtual machine. Every container is a virtual machine. Are you clear? Yeah. Docker. Docker is a containerization software. Docker is a containerization software. What is the meaning of containerization? Packaging the application and application code as a single unit for the execution is called as a containerization. So what is the benefit with the containerization? If you use the containerization, then we can run our application in any system without bothering about underlying softwares. Docker architecture. So Dockerfile contains set of instructions to build Docker image. Okay. So when you are working with the Dockerfile is very important. Dockerfile contains set of instructions to build Docker image. Then what is a Docker image? Docker image is a package which contains code plus dependencies. Docker registry, it is a place where we can store the Docker images. Docker container. When we run the Docker image, then Docker container will be created. Our application will execute inside a Docker container. Every Docker container is one virtual machine. Every Docker container is one virtual machine, which will be created on the host machine. Every Docker container is one virtual machine, which will be created on the host machine. Okay. In order to work with the Docker, then we need to do Docker setup. Okay. Guys, today I'm going to show you Docker setup in the Linux machine. I will take one Linux machine in the AWS cloud and I will do the setup, because in the real time, we will use Linux boxes to perform our application deployment operations. You can install the Docker in the Windows also, but in the real time, we don't use Docker in the Windows. We are going to use the Docker in the Linux machines. Okay, good. Clear. Let me go to Docker setup. So to do the Docker setup, I'm using my AWS account. In the AWS account, every developer should have AWS account. Cloud is very important nowadays. You need to explore the cloud. If you are new to the AWS part, guys, so I have done one crash course on the AWS. Within 30 minutes, you can understand what is AWS. Within 30 minutes, you can understand what is AWS, how to create the account in the AWS, how to practice that. I have done one AWS tutorial, AWS cloud tutorial. So 3 months back, I uploaded one video. So here I explained what is AWS, how to create the account in the AWS, okay, how to create virtual machines in the AWS cloud. So anyone who want to explore the cloud is the future for the software, guys. So it's very, very important. So I have shared that video in the chat box and I will share that in the WhatsApp group also. So just go through that video. So in that video, you will understand several important topics. What is cloud? How to work with AWS cloud? How to create account in the AWS cloud? These are the things I explained in this tutorial. Within 30 minutes, you can understand what is cloud, why, what is AWS, what services available, how to set up the account, how to create virtual machine, how to do the database setup in the cloud, how to do website hosting in the cloud, how to do the domain mapping in the cloud. These topics I explained within 30 minutes, the basic cloud information. It's very, very important for everyone to know about the cloud. Good. So after the session, I will share this video as well. Please go through that. Now, I want to do the Docker setup. Okay. So to do the Docker setup, set of steps I have given in my GitHub repository. So Docker setup is available. In the GitHub, I have given this Docker setup document. So log in into AWS cloud account and create one virtual machine and connect to that virtual machine using Mobile Extra. Then by using these commands, we can install the Docker software and we can verify Docker is installed or not. First, let me complete the step 1. Set up Linux machine in the AWS and connect to that machine using Mobile Extra. Good. Go to EC2. EC2 is a service in the AWS cloud, which is used to create virtual machines. Good. I'm trying to log in into my AWS account. Good. I logged into AWS cloud account. So currently you can see in the AWS cloud, I'm operating from the Mumbai region. Currently, I don't have any instances. Instances count is 0. Let me go and click on launch instance. So I'm giving this as Docker VM. I'm taking one virtual machine with Linux operating system. For that, I'm giving the name as Docker VM. I'm creating this machine by using Amazon Linux AMI. What is AMI and all? You can see in that AWS video, guys. T2 Micro I'm using, which is free tier eligible. This machine is free of cost for 1 year. Key pair. So I don't have any key pair. Let me create a new key pair. I'm creating the key pair as Docker Workshop key pair. In order to connect with the machine, this key pair is required. Click on create key pair. When I click on the create key pair, that key pair is downloaded into my system. So that key pair is used to connect with that machine. Okay, Docker workshop key pair I have created. Default VPC we are using. Security group, I'm going with existing security group. Then that's it. So I am taking one virtual machine. AMI is Amazon Linux and T2 micro instance. One key pair I have created just now. No need to change any network. Default VPC. Security group I'm selecting existing. If you want, you can create the new security group. Then simply click on launch instance. With this, my machine will be launched. Successfully initiated the launch of the instance. One virtual machine I have created in the AWS cloud. So we need to wait till that machine turns into running state. Still it is in the pending state. The machine will come into running state. Once the machine is in the running state, then we can connect to this machine by using MobileXTRM or by using PuTTY. In the video, I have explained that part also, how to connect with the Linux machine by using MobileXTRM. Let me refresh. Yes, my machine is started. It is in the running state. For this machine, public IP will be available. Copy this public IP and connect with the machine. So I'm using MobileXTRM software. It is also free to connect with the Linux machines. Go to MobileXTRM session. Linux machines works based on SSH connection. Click on SSH, remote host. I'm giving my public IP. My machine username is default username EC2 user. Password will not be available. Private key will be available. We have selected PEM file. Select that PEM file. Okay. So go to this PC downloads. In the downloads, I have that PEM file. Just now we created a PEM file. Select that PEM file. Click on OK. So with this, I'm able to connect with my Linux machine successfully. Now you can check it. Who am I? I connected as a EC2 user. Good. Next, we need to install the Docker. Before that, let me check Docker-v. What it is saying, guys? When I use Docker-v, it is saying Docker command not found. So in this machine, Docker software is not available. Just I completed step 1. That means I created a Linux machine and I connected to that Linux machine using MobileXTRM. Now I want to install Docker in the Linux machine. So for this, the commands are available here. So just copy these commands and execute. Sudo yum update. It is used to update the existing packages. Nothing to do because it is the latest machine. All the packages are up to date. So this is the command which is used to install the Docker. Sudo yum install Docker-y. It is going to install Docker software in this Linux machine. Why we are installing the Docker software? To create the images, to run the images, Docker software is required. Docker installation got completed. Then let's start the Docker as a service. Sudo service Docker start. So Docker start created, Docker start is done. Then after, very important step, guys, we install the Docker. Now we connected to this machine as a EC2 user. Now Docker is installed. When the Docker is installed, Docker group will be created. So now I want to perform operations in this machine as a EC2 user. So that's why we are going to add this EC2 user to Docker group. It is a user mode command in the Linux, which is used to add this user to Docker group. When you install the Docker, Docker group will be created, but we want to perform the operations as EC2 user in the Linux machine. So that's why I'm adding EC2 user to Docker group so that we can perform Docker operations. Okay. Once we add the EC2 user to the Docker group, just type exit. Just close the session and reconnect to that session. I have given exit. Then press R to restart the session. Once the session is restarted, then you can execute Docker-v. Now you can see Docker version 24.0.5 is created. Okay. So with this, Docker setup got complete. So in my Linux machine, Docker setup got completed. So we can verify the Docker info. When you execute Docker info, it will show you the information. Currently, how many containers are available? 0. Docker client is installed and debug mode false. Containers 0. Images 0. Okay. Currently, nothing is available. It is a brand new machine. In this machine, we have installed Docker. Okay. Now, in order to work with the Docker, we need to know some Docker commands. Okay, Docker setup, I have given a Git repository, guys. So let me share the Git repository link here. In the notes, I'm giving this Git repository. So when you access this URL in the browser, then you can see the steps. Okay. So this is the Git repository link to set up the Docker in your system. Once the Docker setup got completed, then in order to work with the Docker, we need to use some Docker commands. Sir, what are the commands? The first one is Docker images. The first command is Docker images to display list of Docker images available in our system. Okay, Docker PS to display list of Docker containers running in our system. Okay, Docker images is a command. It is used to display the images which are available in our system. Docker PS to display list of Docker containers running in our system. So let me go and execute a command called Docker images. Now, when I execute Docker images, is there any image available in our system? Guys, please involve for the next 30 minutes practicals. Very, 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 very important. People from YouTube, are you able to follow? Are you able to follow? From the Zoom, guys, able to understand? It's very, 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 very important workshop and very useful. You are getting for free of cost. Please be active for the next 30 minutes because practicals we are doing on the Docker. Theoretically, we understood. We got the clarity. Now practicals also, if we understood, then happily you can keep Docker in your resume. Got it. So I want to check what are the Docker images available in my system. I have taken a Linux machine. So in this Linux machine, I have installed Docker software. I have taken a Linux machine. In this machine, I have installed Docker software. Now, in order to work with the Docker, we are using Docker images. Okay. Docker images is a command. What is the purpose of the Docker images command? It will display what are the images available in our system. Currently, is there any image available or there is no image available in our system? Currently, any image available? There is no image available in our system. Currently, there is no image available in our system. Okay. Can we check any container is running in our system? Docker PS. Now, any container is available in our system? No container is available in our system. So now what we need to do? Guys? We need to download the image and we need to run the image. We need to download the image and we need to run the image. In order to download any image, okay? So here you can use a command called Docker pull command with the image name or image ID. Image ID or image name you can use to download Docker image. Docker pull image name or image ID. Then Docker run, you can use image ID or image name to run Docker image. Container creation. So whenever you want to download any Docker image, you can go for Docker pull command. So Docker pull command, you can pass Docker pull command with image ID or image name. So it is going to download a Docker image. Once the Docker image is downloaded, you can run the Docker image. Whenever you run the Docker image, it is going to create a Docker container. Okay. So if you want to delete the image, Docker RMI, image ID or name. So when you give image ID or name for the RMI command to delete Docker image. Okay. To delete the Docker image, you can go for that. Docker RM, container ID. Okay. To delete Docker container. Like this, there are several commands available on the Docker. Okay. Right. Docker images, Docker PS, Docker pull, Docker run, Docker RMI, Docker RM. Okay. Now, sir, where we can find the Docker images? That's where Docker Hub is available. You can go to Docker Hub in order to understand the Docker image names, image IDs. So everyone can create the account in the Docker Hub. So Docker Hub is available where you can find the images. For example, I want to run MySQL database. What is the image name for that? You can find out in the Docker Hub. Login.docker.com. It is a Docker Hub. If you don't have an account, you can sign up. So my username and my password. I have already account in the Docker Hub. So as part of our batches, we are using Docker in our Spring Boot and project batches in the DevOps. So we are using Docker. So I already created an account in the Docker Hub and I stored lot of images in the Docker Hub. So you see one of my image I created for Spring Boot image. You see how many people downloaded my Docker image? 67,000 people downloaded my Docker image. So once I create the Docker image and upload in the Docker Hub, anyone can pull my Docker image and they can run my Docker image. So this is a Spring Boot application REST API. So they are pulling my Docker image. 67,000 people pulled my Docker image because it is a public image and they are running my Docker image. So this is the name of my Docker image. 2 years ago, I pushed this Docker image into Docker Hub. As of now, these many people pulled my Docker image and they are using my Docker image. Okay, good. So this is my Docker Hub account. All these are my Docker images which I have stored. So I have stored one Java web application image. 3,500 people pulled that. Similarly, I have stored Python images, Angular images, Python Flask application I have stored here. So many Docker images I have in my Docker Hub account. Got it? Fine, that's fine. So here I want to search for the Docker images. Okay, so you need to create the account and log in into Docker Hub, search for the Docker Hub. You can search for the image. I want to go with first Hello World Docker image, just a basic application. Okay, so there is a Docker image with a name called Hello World. Okay, so 1 billion people, 1 billion people downloaded this Docker image. This is official Docker image. Okay, you can create the Docker image for your application and Docker is providing some predefined images also. You can create your own image and you can pull the Docker images which are already available. Okay, so go to Hello World image. What is the name of the image? Hello World. They're giving the syntax also. Docker pull Hello World. What is a Docker pull? Docker pull is a command which is used to download the image. What is the name of the image? Hello World. You just copy this, then go here. Before I'm going to execute this command, let me show you Docker images. Nothing is available. Now I am using Docker pull Hello World. Now enter. It is going to download an image with a name called Hello World. Now you see Docker pull Hello World image I have downloaded. Using the default tag, pulling from the library and pull completed status, downloaded a new image for the Hello World. So from the docker.io.library, it pulled Hello World image. After pulling the image, you can check Docker images. Now you see there is an image with a name called Hello World. This is image ID. 5 months ago, this is created and size is 13 KB. I have the Docker image. Once the Docker image is available, can we run the Docker image, guys? Once the Docker image is available, can we run the Docker image? What is the command to run the Docker image? Docker run image ID or image name. You check it. Docker run Hello World. That is the name of the image. Image name. Docker pull to download the image. Docker run to run the image. When you run the image, what will happen? Docker container will be created. Okay. Hello World is just a basic image which will give you Hello World message. Enter. Right. So when I execute Docker run Hello World, it is giving a message hello from Docker. That means that image is executed, container created, and a container has given you a message. This message shows that your installation appears to be working correctly, boss. Your Docker setup is successful in the system and you are able to run the Docker image and you are able to create the Docker container. So how it is working in the background? They have given some steps. Could you please read these 4 points? You will understand what happened in the background. Could Could you please read these steps so that you can understand what happened in the background? Come on, guys. You understood what happened in the background? The Docker client. So in our machine, we have installed Docker, right? In our machine, we have installed Docker. So what happened? Docker engine is available. So that is going to install Docker client. Okay. So once we install the Docker client will be available. Docker client contacted the Docker daemon. Docker daemon is a background process that is available in our system. The Docker daemon pulled the hello world image from the Docker hub. The Docker daemon created a container from the image, which producing the output. Docker daemon, that means whenever you execute any Docker command, Docker client will contact the Docker daemon. Docker daemon is a background thread, which is going to do all the Docker operations. Okay, good. So you got the concept how to check the images, Docker images. There is one image available. Docker PS, no containers are running. Docker PS-A, it will display the containers which are stopped also. Docker images command will display what all the Docker images are available. Docker PS command will display the containers which are in the running state. Okay. The Docker PS-A, it will display the containers which are running as well as stopped. So there is a container which is stopped, exited, status is exited. So whenever I execute Docker run hello world, it is a standalone application image. Okay, it is just producing hello from Docker, then it is stopping the container. Right. So how to check the containers which are stopped? By using Docker PS-A. Okay, see here, I executed image for 2 times. So container created 2 times and it got stopped. One container stopped 3 minutes ago. Another container stopped 11 seconds ago. 2 times I have created that image. Okay. Good. Now, how to delete the container, guys? How to delete the container? Docker RM container ID. Docker RM container ID. Okay. So it is used to delete the container which is in the stopped state. Now, I have deleted the container. Docker PS-A. All the containers got deleted. Now, Docker images available. So Docker images, there is one image available. How to delete the image? Docker RMI, image name or image ID. Anything is fine. I have deleted my Docker image. RM command to delete the container with the container ID. RMI command to delete the image with the image ID. Okay. So now you see Docker images. Everything is clean in my system. Nothing is available. I pulled one image, I executed that image, container got created, now I stopped it. Okay, I deleted the container and I deleted the image also. Are you able to follow me? What are the commands that we used as of now? Docker images command to display list of Docker images available in our system. Docker PS to display list of containers running in our system. Docker pull command to download a Docker image. Docker run command to run the Docker image. Docker RMI command to delete the Docker image. Docker RM command to delete a Docker container. Are you clear? Now, sir, why this container got stopped? That is hello world image now. That's why it got stopped. Okay. If you run any web application, that container will not be stopped. Whenever you run any web application image, that container will not be stopped. It is hello world is a basic image. Okay. And one more thing that we need to understand here. Earlier I used Docker pull hello world. Then after I executed by using docker run hello world. Instead of this pull command, directly I will use docker run hello world. But currently in my system, docker image hello world is available or image hello world is not available. Guys, in my system, docker image is available, hello world are not available. It's not available. Then what will happen when I execute this run command? Then what will happen when I execute this run command, guys? What will happen when I execute this run command? Image not found, or it will pull and run the image. You need to understand, Docker is intelligent here, guys. Docker is intelligent here. Whenever you execute run with image name, first it will check for the image in the local. Unable to find the image locally. Whenever you execute docker run hello world, unable to find image locally. First it is giving the priority for the local images. If the image is available in the local, then it will pull that image and it will run that image. So if first it is checking in the local, if the image available in the local, it will use that image and it will create the container. But in this scenario, the image is not available in the local. So that's why it is going to download that image. Then it is going to run the image. So do we need to pull? Is it mandatory to pull to run, or directly you can run also? Now you can tell me, is it mandatory to pull the image to run, or directly we can execute run command? It's not mandatory to pull. Directly we can execute. When we execute directly, then what is happening? When we execute directly, then what is happening? It is checking in the local. It is checking in the local. If available, run. If not available, then pull and run. You got it? Got my point? Okay, very good. So now, Docker images available. One image is available, and Docker ps-a. Container is in the running state, or container is in the stopped state? Container is in the running state, or container is in the stopped state? In the stopped state. Okay. Can we delete the container which is in the stopped state? Yes, we can delete it. What is the command? Docker rm container id. What is the command to delete the image? RMI. Here we can do one more thing. Docker system prune -a. When I execute Docker system prune -a, all stopped containers, unused images will be deleted. In the single shot, I want to clean up my system. All stopped containers, all unused images, I want to delete. Docker system prune -a. So this will delete all stopped containers, all networks, all images without any container association will be deleted. Yes. Yes. So now see, 13 KB space reclaimed. So it deleted stopped containers and unused images. Docker system prune -a, which is used to clean up our Docker server. Okay. Delete, clean up. Clean up. I mean, it is going to delete stopped containers and unused images. If your image is not associated with any container, then that will be deleted. Let me save this file, guys. So after the class, I will share this notes. Okay. So I have shared the WhatsApp group link, right? In that WhatsApp group, you will get this notes. Okay. Good. Yeah. So you understand what is the purpose of Docker system prune -a? Guys, you understood what is the purpose of Docker system prune -a? What is the purpose of Docker system prune -a? To delete all the stopped containers and unused images. To delete all the stopped containers and unused images, we are going to do this. For YouTube viewers also, I'm going to share WhatsApp group link in the live chat. You can check that and you can join. The people who are watching in the live, you will get that in the chat box. Okay, 1 minute. After the class, these notes and this video, you will get it. Yeah. For the live people in the live chat, the people who are watching from YouTube, I have given WhatsApp group link in the live chat box. You can join in that so that you will also get the notes and document. Okay, good. Fine. So we understood the Docker commands. Now, for example, I want to run a Docker container for the image which is already available. So we want to understand how to run the existing Docker images and how to create a Docker image for our application. Both we are going to understand. Okay, so both we are going to understand. Perfect. Now here, if you observe, I have shown you one of my famous Docker image, which is Spring Boot REST API. Okay, so Spring Boot REST API is available. I want to take this image and I want to run this image. Okay, so what is the command? Docker pull image name. So this is the command in order to run this Docker image. Ashok IT / Spring Boot REST API. This is my Docker image. So I can first pull this image and I can run this image. Instead of pulling, can we run directly also? Guys, instead of pulling, can we run directly also? Is pull mandatory? Is pull mandatory or is pull optional? Is pull mandatory or is pull is optional? Optional, right? Directly you can execute run command. But here let me show you how to pull this. Clear. Currently in my system, no images are available. No images are available. And can you check, is Java installed in my system? Guys, is Java installed in my system or Java is not installed in my system? Java is not available. Spring Boot application is a Java-based application. To run the Spring Boot application, Java is required. But do I need to install the Java to run my Spring Boot application here, which is available as a Docker image? Not required, right? Not required, right? So just to pull the image, Docker pull Ashok IT Spring Boot REST API. This is my image name. Ashok IT / Spring Boot REST API. Execute. It is going to run a Docker image. It is going to pull the Docker image, guys. Yes, the Docker image is downloaded from Docker Hub. You can also pull my Docker image because this Docker image is a public image available in my Docker Hub account. So this is a public image. Anybody can pull this Docker image. Once the Docker image got pulled, you can verify whether image is available or not. Docker images. Can you check it? So 23 months ago, I have created this Docker image. Around 2 years, almost 2 years back, I created this Docker image. Ashok IT / Spring Boot REST API is my image name. Now, can you tell me the command to run this image? This is my Spring Boot application, which I have Dockerized. How to run the image? What is the syntax? Docker run. Either you can take image name or you can take image ID. I'm using Docker run image ID. Now you check it. What is happening? Wow. It is running our Spring Boot application. Is it running our Spring Boot application or not? But do we have Java in this machine? Do we have Java in this machine? No. Then how this Spring Boot application got executed? How this Spring Boot application got executed? Docker is taking care of that. To run my application, Java is required. So what I have done for this project? For this project, I have created a Docker file. My Spring Boot application code is available. For that, I have created a Docker file. Using the Docker file, I created a Docker image. The Docker image I have stored in the Docker Hub. Now from the Docker Hub, I am pulling the image and I am running the image. When I run the Docker image, Docker container is created. Inside the container, my application is executing. Now, sir, can we access this application which is running in the Docker container? Can we access this application which is running in the Docker container? No. The answer is no. At this moment, you cannot access this application running in the container. The reason is virtualization. So this is my Linux machine. So my machine is available. The host OS is Amazon Linux. Okay. I have a machine. In this machine, I have Linux operating system. I created a Linux machine in the AWS cloud and I connected to this Linux machine by using MobiXtrom. Then in that machine, I have installed Docker. Then by using Docker, I pulled a Docker image. Using this Docker image, I created a Docker container. So Docker container means what? Docker container means what, guys? Docker container is a virtual box. Now, so in one Linux machine, another Linux machine is running. I know IP address of my Linux machine. I know IP address of my Linux machine. So which is the public IP of my machine. But the application is running in my machine. The application is running in my machine. The application is running in the Docker container. Guys, the application is running in my machine. The application is running in the Docker container. Come on, fast. The application is running in my machine and it is running inside the container. It is running inside the container. So is there any relation between this container and this host machine as of now? Is there any relation between the container and the host machine? There is no relation. There is no relation. That's the reason you cannot access that REST API. That is the reason you cannot access that REST API. Okay, I have taken one machine. In that machine, Linux operating system is available. That's okay. In that machine, I installed Docker. Fine. By using that Docker, I downloaded a Docker image and I executed a Docker image. When I execute the Docker image, Docker container got created. Docker container got created. But is there any relation between my machine and that Docker container? Is there any relation between my machine and that Docker container, or there is no relation? No. There is no relation. Got it. So then how we can access the REST API which is running in the application, which is running in the Docker container? This is not the right approach to run the container to access it outside. This is not the right approach to access the container outside. If you want to allow the people to access your container outside, you need to go like this. Docker pull -p 8080:8080 / Docker run, basically. Docker run -p 8080:8080 and our image name. Sir, what is this -p? -p is called port mapping. I need to establish the relation between this container machine and this host machine. My container is running on the port number 8080. So I want to map that to the 8080 port. Okay. Container port is 8080. Host port also I am mapping to 8080. So if you establish the port mapping, then we can access our REST API by using host machine public IP. So currently my container is running, but that container is running inside the virtual machine. We can't access outside because we don't know what is the IP of the virtual machine. So virtual machine is created inside the host machine. I know the IP address of host machine, but my application is not running on the host machine. My application is running inside the container. Container means virtual box. I don't know address of the container. Then what I will do? I will establish the relation between container machine and host machine by using port mapping. So for that, we will use a flag called -p. -p represents port mapping. So when you are running your Docker container, you need to specify port mapping. Then you can access this application outside by using host machine public IP. You understand what is the purpose of the port mapping? It is used to establish the relation between host machine and container. Okay, so host machine container relation. What is the port number it is using, guys? My container using port number, my Spring Boot application running on the port number 9090. You can see here. Tomcat server started. Which port number? 9090. Java developers. Spring Boot will use Tomcat as an embedded container with default port 8080. But for this application, I changed the port number to 9090. So what is my container port number? 9090. So what I will do, that 9090, I will map to 9090 my host machine also. So host port and container port we are going to do. If you run application like this, then you can access that application outside. Let me stop the container, Control C, which is stopped. Now let us check it. Docker ps-a, my container stopped 4 seconds ago. It is exited. Okay. Now let me do Docker system prune -a. Delete everything. I don't need anything. Delete it. Now Docker images. Docker images. No images are available. Docker ps-a. Nothing is available. Okay. Now let me go and execute my image. Create a container. When I am running the container by using a Docker image, I'm doing the port mapping. The container is running on the port number 9090. Host port and container port is available. So if you do the port mapping, then we can access our REST API outside. Docker run -p 9090:9090 host port and container port, and this is my Docker image name. So pull I am not doing. Directly I am going for run. So it will check in the local. If available, it will run that. If not available, it will download and it will run that. So before, once again, I'm going to show you in my system, Java is available or not. In my host machine, Java software is available or Java software is not available. In my host machine, Java software is available or Java software is not available. Java software is not available. Okay, just run the image. Docker run -p 9090:9090 name. So this is name of the image, public image in the Docker Hub. Now run this. Unable to find the image in the local. Now it is pulling that image from the Docker Hub and it is going to run that Docker image. You can see the console. My Spring Boot application getting started. It started with the port number 9090. I mapped that to the host port 9090. Now, so here, now be careful. We have created one container. That container port is 9090. That container port we mapped to host port. Port mapping we have done because I want to access this outside. Okay, I know the public IP of my machine. This is my machine public IP. My Linux machine public IP, which is running in the AWS cloud. In that Linux machine, Docker is installed. Using Docker, I executed a Docker image, Docker container created. For that container, I have done the port mapping. Now, to access our REST API from this machine, what we need to do? First, we need to enable the port number in the security group. Okay. So for this machine, go to security tab. At the time of creating this machine, we used one security group. Go to that security group, edit the rules, custom TCP 9090. I have mapped this machine to, I have mapped this container to 9090 host. Okay. So you need to go to the security group inbound rules and enable 9090. Okay. So in the AWS video, I explained what is the security group and all that stuff, guys. So currently I'm enabling 9090. The reason, my container machine, my container running on the 9090 in the host port I have mapped to 9090. That's why I'm enabling 9090 in the security group inbound rule. Save the rules. That's it. So we are good. Now we can access our REST API, which is running in the Docker container. So this is my machine details. Go to public IP, go to public IP, go to browser, public IP colon 9090/welcome/John. You give the name. Now see here. So this is my REST API URL pattern, welcome. John is the name that is expecting as a path parameter. If I give any name, for that name, it will say a greet message, welcome to Ashok IT. So if I give my name as Ashok, it will give Ashok, welcome to Ashok IT. So this is the URL of my REST API. So where is this REST API URL? Where is this REST API is running? Can you hit that URL? Give your name in the URL and test it. And let me know, are you able to access my REST API, which is running in the Docker container that is available in the Linux machine? The people in the Zoom, I gave the URL for testing purpose. Are you able to hit that? Are you able to hit that URL? Give your name and try that. Is it giving the dynamic response? From where you are getting the response? It is working. That's awesome, right? So now, if I want to run this application in the 10 environments, if I want to run this application in the 10 environments, do I need to bother about softwares? If I want to run this application in the 10 environments, do I need to bother about the softwares required? So what you need to do? If you want to run this Spring Boot application in the 10 environments, then what we need to do? Come on, guys. Just install the Docker software and run the Docker image. Install the Docker and run the Docker image so that your application will execute in any machine. Okay, now go back to our previous diagram. If I have multiple environments like this, if I have multiple environments, dev, SIT, UAT, pilot, prod, do I need to bother about versions? Do I need to bother about the dependencies? Do I need to bother about the versions? Do I need to bother about underlying operating system? Nothing. A big no. So our life simplified with Docker. As a developer, when you write the code, you can test that code in any environment. And the DevOps people, easily you can deploy the application into any environment with the help of Docker. That is the power of the Docker. That is the power of the Docker. Docker is called as containerization software. Docker is called as containerization software. So what is the meaning of containerization, guys? What is the meaning of containerization? Package our application code and dependencies as one unit for executing in any system. Code will be available. Developers will write that code. To execute that code, some dependencies are required. What dependencies are required, we will specify that in the Docker file. Okay. Once the Docker file is available, we will build that Docker file so that Docker image will be created. Once we build the Docker file, Docker image will be created. Once the Docker image is created, we can store the Docker image in the Docker Hub. Once the image is stored in the Docker Hub, then you can take that Docker image and you can run that image in any machine. In order to run the image, you need to install the Docker software. That is one part we need to do. Once the Docker software got installed, you can run the image. When you run the image, Docker container will be created. Once we run the image, Docker container will be created. What is the meaning of a container? What is the meaning of a container? Can I say it is one Linux box? Can we say it is one Linux box? Yes, it is one Linux box. Now you see, so many people accessed our application. So my application logs are generated. Welcome controller, welcome message, execution start, execution end, execution start. I implemented logging in my application. It is my Spring Boot REST API. So in this Spring Boot REST API, one GET request method I have implemented. For that method, I have implemented logging also. So the people are accessing my application. So the logs are generated. Can you hit the URL again? You can see the logs which are getting generated here. Now, can you guys see the logs are generating? The logs are coming here. The logs are scrolling or not? Yeah, dynamic logs. So application is running inside container. Container is running inside my Linux machine. So in one Linux machine, another Linux machine got created. That is virtualization. So with one image, we can create any number of containers. Container means virtual box. Containers created based on the virtualization. Okay. And here, one more small change, guys. Yeah, stop hitting the URL. Stop hitting the URL. So when my container is created by using this command, docker run -p and image name. Can I execute any other command? In this terminal, can I execute any other command, guys? Is my terminal open to execute any other command? No. Can I run one more container here? Can I see how many containers are running? Can I see how many containers are running? No. I'm not able to execute any other command. I'm not able to execute any other command because I am blocked here. I am blocked here. So let's make a small change. Let's make a small change. I want to run my container in the background, guys. I want to run my container in the background. So what is the meaning of running the container in the background? What is the meaning of running the container in the background? I want to run the container in the detached mode. Okay. So if I run the container in the detached mode, my container will be executing 24/7 and I can execute other commands also. Let me stop it. To stop this container, Control C. I'm going to press Control C. When I press Control C, the container got stopped. Good. So let us see Docker ps-a. So what is the status of my container? What is the status of my container? It stopped, exited. Okay. Now what we can do is Docker system prune-a delete. Everything is deleted. Okay. Now you can check Docker images, not available. Docker ps-a, not available. It is deleted. So what we need to do now? We need to run the container in the detached mode. How to run the container in the detached mode? How to run the container in the detached mode? To run the container in the detached mode, same command, just one option I have to add. Docker run -d. That's it. So earlier I used only -p for the port mapping. Now I am using -d. What is the meaning of -d? What is the meaning of -d? What is the meaning of -d? Come on, guys. What is the meaning of -d? Detached mode. Okay, execute. It is not able to find the image. it is downloading the image and it is going to run the image. Okay, Docker pulled my image and it is executing my image as a container. My container is created. Now, am I open to execute other commands? Yes. Now you can check Docker images. So it has pulled my Docker image. It pulled my Docker image. Then Docker PS. Now you can see my container status is up. My container is running and this is the port mapping. My container is running and this is the port mapping. You got my point? Now, can we access this application? Aram se, you can access it because it is running now. You can give the name, you can give any name and you can access it. Charles, welcome to Ashok. Yes, I'm able to access. Can you hit the URL and check it now? I am running my container in the detached mode, guys. I'm running the container in the detached mode by using -d option. Docker run -d, -p. -d means detached mode. -p means port mapping. And this is my image name. This is my image name. You got my point? You got my point? Good. So once you run the Docker image in the detached mode, is it printing the logs or it is not printing the logs? Is it printing the logs or it is not printing the logs? No. Then how to check the logs? For that, we can go for Docker logs container ID. It will show you the logs of the container. Docker logs container ID, then it is going to show you the logs of the container. If you run the container in the detached mode, logs will not be displayed directly. Then you need to check it. Docker PS will display the containers running. Then Docker logs, you need to give the container ID. With that container ID, you can check the logs of your container. So first let's understand what is this Kubernetes and why we need to learn this Kubernetes and where we are going to use this Kubernetes software. First of all, Kubernetes is also called as K8s. So some people will call it as K8s, some people will call it as Kubernetes. K8s nothing but between K and S, there are 8 characters available. That is the reason people will call this as Kubernetes. Kubernetes is an open source orchestration platform. What is the meaning of open source orchestration platform? You no need to pay the money to use the Kubernetes. Kubernetes is free of cost. Kubernetes is free of cost and open source. And it is called as orchestration platform. Orchestration is nothing but management, guys. So in the last few days back, we discussed about Docker. Docker is called as containerization software. Kubernetes is called as orchestration software. Orchestration is nothing but management. So instead of we are creating containers for the application, instead of we are scaling up the containers, scaling down the containers, we can use Kubernetes to manage our Docker containers. So nowadays, every application is getting deployed by using Docker. Docker we are using to containerize the application. Here, whatever the containers you want to create, the containers management we can do by using Kubernetes. That is the reason it is called orchestration platform. In the simple terminology, orchestration is nothing but management. It is used to manage our Docker containers, guys. Fine. So here, this Kubernetes software we are using to manage our container. Container means container is a box where we are going to run our application. This Kubernetes software developed by Google. Google company developed this Kubernetes software and later they donated to other organization. CNCF organization is available. Google developed this Kubernetes software and they donated to CNCF organization. And what we can do by using this Kubernetes? This Kubernetes software provided a framework. Kubernetes provided a framework which is used to manage complex tasks related to application deployment, application containers scaling, application deployment by using containers. Okay, scale up the containers, scale down the containers, like the deployment complete application deployment process will be taken care by Kubernetes. So in the real time, application deployment process will be taken care by DevOps team, right? So the DevOps team is going to use this Kubernetes software to manage application deployment. So that is the reason Kubernetes is called as one of the most famous DevOps tool in the market. So developers and DevOps people should know what is this Kubernetes and how to work with the Kubernetes. Without asking the questions on the Kubernetes, the DevOps interview will not be completed. And nowadays, in every interview for the developers also, they are asking questions related to Kubernetes because this is very powerful software to manage our application deployment process. Docker will be available. Kubernetes also will be available in order to deploy our application. I want to run my application. Okay, currently people are following microservices architecture to develop the application. In the microservices architecture, front-end application will be available, back-end microservices will be available. 10, 20, 30, 40 like that. Multiple back-end microservices will be available. Every microservice we are going to deploy as a separate container. So like this, in one project, multiple containers will be available. So all these are Docker containers. All these are Docker containers. For example, I have 50 microservices in my application. So if I want to deploy those 50 microservices, then 50 containers I have to create. And for one microservice, I want to do the load balancing. Instead of running my microservice in one Docker container, I want to run my microservices in 20 Docker containers for the load balance. So here, if you want to create the containers, if you want to manage the load balancing containers, that will become very difficult process. So that's why in order to manage our containers, we are going to use orchestration platform. That's where Kubernetes comes into picture. Kubernetes is called as orchestration platform. So could you please respond in the chat box? Are you clear? What is Kubernetes? Why people will use Kubernetes in the market? Are you guys clear what is Kubernetes? Why people are going to use Kubernetes? Kubernetes is called as orchestration platform. What is the meaning of orchestration? Orchestration is nothing but management. Orchestration nothing but management. It is used to manage Docker containers. What is a Docker container? Container is nothing but a box where our application deployment will happen. Container is a box where our application will be executed. So for one application, multiple containers will be available in the real time. So one application we are going to deploy by using multiple containers to manage the load. Suppose if I am having multiple microservices, for every microservice, I want to create multiple Docker containers. So instead of we are creating the Docker containers manually, we are going to use Kubernetes in order to create the containers and in order to manage the containers. Okay, developers should know how to work with this Docker and Kubernetes. DevOps people also should know how to work with this Docker and Kubernetes. All right, next one. So if you see application architecture, I'm taking one microservices based application. Microservices, one of the most famous architectural design pattern to develop the projects. Earlier, people used to develop the project by using monolithic architecture. Monolithic architecture, nothing but everything will be developed in the single project. Everything will be developed in the single project and single container will be created to deploy the application. But today, in the today's market, monolithic architecture got outdated. People are going for microservices architecture. I'm taking a simple example of e-commerce application. If you go for this e-commerce application, product service available, order service available, customer service available, payment service available, cart service available, wishlist service is available. So like this, multiple services available in our microservices architecture. Okay. Now, for every microservice, separate database is also available. This concept is called DB per service concept. So every microservice is a separate project which will run in the separate server. And for every microservice, separate database is also available. Now, I want to deploy this application. Okay, to deploy this application, we are going to use Docker containers. Now, for this product service, I need to create one Docker container. For other service, I need to create one Docker container. For customer service, I need to create one Docker container. Like this, for every microservice, we need to create the Docker containers in order to run our application. Docker is used as containerization software, which is used to run our application in any machine. Now, for example, for other service, so many requests are coming. So one server I am using to run the application. That means one server, nothing but one container. Other service is currently running in one container. If other service is running in one container, that cannot handle the load, because today there is a big billion day offer available in our application. Lakhs of customers are placing the orders in the e-commerce project. When the lakhs of customers are accessing our application, then one container is not sufficient to handle that load. Then what we need to do, instead of running our application, our microservice in one Docker container, I want to run my application in multiple Docker containers. I want to create 20 Docker containers. If so many requests are coming, I want to increase the containers. If a more number of requests are coming, I want to increase the containers. If less number of requests are coming, I want to decrease the containers. So if any container is crashed, then I want to replace that with the another container. So like that, lot of management operations are required on the Docker containers. So to manage these Docker containers manually, it will take a lot of time and it is a risk also. That is the reason we need to automate our containers management functionality. To automate that containers management functionality, orchestration tools will be used in the market. Kubernetes is one of the orchestration tool which is used to manage the Docker containers of our application. Are you able to understand what is the problem when you are going for application with microservices architecture? Multiple microservices will be available for one project. For every microservice, we need to create a Docker container, and one Docker container is not sufficient. Multiple Docker containers we need to create for one microservice. For example, for other microservice, I created one Docker container. So with one Docker container, one server will be available to handle the request. If more number of requests are coming, then one container is not sufficient to handle the load. Then we need multiple containers. So creating multiple containers, increasing the count of the containers, decreasing the count of the containers is called management. That management work will be taken care by Kubernetes. So what are the benefits we are going to get with the Kubernetes? There are several benefits available with the Kubernetes. Before going to understand, are you clear why we are using Kubernetes in the market? Are you guys clear with my point? Why we are using Kubernetes in the market? It is used to manage containers, like create the containers, delete the containers, scale up the containers, scale down the containers. Complete containers management will be taken care by Kubernetes software. Kubernetes is called as orchestration platform. Docker is called as containerization platform. What are the advantages we are going to get with this Kubernetes? Okay, what is the first advantage with the Kubernetes? The first advantage with the Kubernetes, it is providing a platform to manage the containers. That is called container orchestration. Kubernetes is used to orchestrate our containers. So the best thing that with the Kubernetes is it is used for container orchestration purpose. Then what is the second advantage with the Kubernetes? Scalability. Scalability nothing but based on the demand, it can increase our containers or it can decrease our containers. If a more number of requests are coming, then containers count should be increased. If less number of requests are coming, then containers count should be decreased. That means it has to adjust the infrastructure capacity. It has to adjust the infrastructure capacity based on the demand. It has to adjust the capacity based on the demand. That is called scalability. That is called scalability. Suppose, for example, today my application is running in one container, but so many users are accessing my application. When multiple users are accessing our application, one container is not sufficient to handle the load. Then we need to create multiple containers in order to handle the load. Then we need to increase the containers. If more number of requests are coming, containers count should be increased. If less number of requests are coming, then we need to decrease the containers. That is called scalability. Kubernetes will take care of that scalability. Next one, self-healing is the another advantage we have with the Kubernetes. So what is the meaning of that? Self-healing. Self-healing nothing but if any container is damaged. For example, I'm running my application in two containers. One of the container got damaged. That means due to some problem, that container got stopped. If the container is stopped, then our application will be down. So to resolve that problem, Kubernetes will perform self-healing. Nothing but if any container is damaged, Kubernetes replace that and will with the another container. Kubernetes will replace that with the another container. So that is self-healing capability. If anything is damaged, it will create another container in that place. That is called self-healing. And the next one, load balancing. So here, when our application is running in multiple containers, it will distribute the load to all the containers in the round robin fashion. Instead of sending all the requests to single container, Kubernetes is going to take care of this load balancing concept. So these are the advantages available when we go for Kubernetes concept. Kubernetes is providing container orchestration platform, and it is providing scalability. It is providing self-healing capability, and it is taking care of load balancing also. Are you guys clear? So just summary, orchestration platform, it is used to manage the containers. It is providing a platform to manage your application deployment, your application scalability, your application load balancing. Now, this Kubernetes software developed by Google company, and they donated to another organization. So if you want to work with Kubernetes, then you should know the Kubernetes architecture. Very, very, very important concept. Kubernetes architecture. Kubernetes works based on cluster architecture. Kubernetes works based on cluster architecture. So can anyone tell me what is the meaning of a cluster? Do you know what is a cluster? Any idea? What is the meaning of cluster? Any idea? Come on. What is the meaning of cluster? Do you have any idea? Cluster is nothing but group of servers. Cluster is nothing but group of servers. Kubernetes works based on cluster architecture. What is the meaning of cluster? Cluster means group of servers. So if you want to use Kubernetes, then you need multiple servers. If you want to use Kubernetes, then you need multiple servers. With one computer, you can't set up the Kubernetes. So group of computers required, then we are going to set up the Kubernetes. Kubernetes works based on cluster architecture. Cluster nothing but group of servers. Let us see the Kubernetes architecture diagram. This is the Kubernetes architecture diagram. Just read all the components which are available in the architecture. Then we will understand how to work with this, and we will do post-mortem on this architecture, guys. Before we are going to understand, just have a look about the architecture and see that. This is Kubernetes cluster architecture. This is called Kubernetes HA architecture, high availability architecture. This is called as Kubernetes high availability architecture. Just look at this. Just look at this. What is this? What are the components available? Control plane is available and worker nodes available. Inside the control plane, API server available, scheduler is available, controller manager, etc. Inside the worker node, pods available, containers available, Docker available, kubelet is available, kube proxy available. Okay, right. And user interface is available to connect with the control plane, and kubectl is available to connect with the control plane. If you see in the Kubernetes architecture, the first important thing that is a control plane. Control plane is like a manager for the team. Control plane is like a manager for the team. Control plane is going to manage the team members. The team members nothing but worker nodes. Worker nodes are called as team members here. Control plane is also called as master node. So in the Kubernetes, control plane is also called as master node, which will manage everything in the Kubernetes. Okay, if you want to deploy your application, then you need to inform to the control plane. Whatever you want to perform in the Kubernetes, whatever the task that you want to do by using Kubernetes, that a task you will give to the control plane. Control plane is also called as master node in the Kubernetes. Inside the control plane, API server available, scheduler is available, controller manager is available, and etcd is also available. API server, scheduler, controller manager, and etcd. We'll talk about that. As of now, what is the meaning of control node? Control plane. Control plane is nothing but master node, which will manage everything in the Kubernetes. Okay, guys. Next up, this control plane will be connected with the worker nodes. Worker nodes nothing but the machines in which our application will execute. Worker nodes are nothing but employees. Control plane is nothing but manager. So whenever a task comes, whenever a requirement comes, that requirement will go to control plane. Then control plane will assign the task to the worker node. Inside the worker node, our application will be executed as a container. That container will be created inside the pod. In the Docker, directly we can create the container, but in the Kubernetes, we are going to create the pods. Pod is nothing but a process. So whatever the application that you want to execute, for that application, pod will be created in the Kubernetes. Pod is nothing but a process. Inside the pod, our containers will be created. Inside one pod, you can create multiple containers also. Okay, so you can create multiple pods. Suppose I want to run my application in multiple servers. Then multiple servers, nothing but multiple pods we are going to create. So here inside the Kubernetes architecture, one control plane can have multiple worker nodes also. So for a high availability, worker node 1, worker node 2, I'm taking. So whenever you deploy your application, for your application, pods will be created inside the worker node. Inside the worker node, pod, inside the pod, container will be available, and Docker engine will be available, kubelet will be available, and kube proxy will be available in the worker nodes. Now, I want to deploy my application. So to deploy one application, Docker image is required. First, we need to create Docker image for the application. By using that Docker image, we will create the pods in the Kubernetes. Inside the pod, container will be created. That means as a programmer or as a DevOps engineer, I need to tell to the control plane to deploy my application in the Kubernetes cluster. That means we need to communicate with the control plane. In order to communicate with the control plane, there are two ways available. By using UI page also, by using UI pages, you can communicate with the control plane. That will give you a graphical user interface in order to communicate with the Kubernetes control plane. If you don't want to use graphical user interface, then you can use kubectl, kubectl. People will call it as a kubectl. Some people will call it as a kubectl. Some people will call it as a kubectl. Kubectl is a command line utility which is used to communicate with the Kubernetes control plane. For example, I want to deploy my application in the Kubernetes cluster. To deploy our application in the Kubernetes cluster, we can use kubectl software. By using kubectl software, we can communicate with the control plane. Then control plane will communicate with the worker nodes in order to complete the task. I have a Docker image for my Java application. By using that Docker image, I want to create containers. So here we are going to give that information to the control plane. Then control plane will give the information to the worker node. Inside the worker node, our application will be deployed by using a concept called pod. By using a concept called pod concept. Are you guys able to understand? Are you able to understand? Kubernetes control plane and worker nodes and kubectl. So Kubernetes works based on cluster architecture. So in the Kubernetes cluster, group of servers will be available. What are the main things here? One is control node. Control node is also called as master node. Control node or control plane. People will call it as control node or control plane, or we can call as master node. And the second thing, worker nodes. Okay, multiple worker nodes will be available. And the third one is kubectl. Okay, what is the control plane in the Kubernetes, which will manage the works in the Kubernetes cluster? So whatever the task that we are giving, that a task will be given to the control plane by using kubectl. What is this kubectl? Kubectl is a command line utility which is used to communicate with the control plane. Kubectl is a command line utility which is used to communicate with the control plane. Okay, so inside the control plane, what is available? Inside the control plane, API server is available, scheduler is available, controller manager is available, and etcd is available. etcd is available. Now, let's understand them one by one. Okay, first thing is control plane. So Kubernetes control plane will contain API server, scheduler, controller manager, etcd. When we talk about Kubernetes architecture, we need to talk about control plane. Inside the control plane, what is available? Inside the control plane, API server available, scheduler is available, controller manager is available, and etcd is available. Coming to the worker node. So what is a worker node? Worker node means which will perform the task based on the instruction given by the control plane. So I will give instruction to control plane. Control plane will give the instruction to the worker node. Inside the worker node, our application will be executed as a pod. So what is available inside the worker node? Inside the worker node, pod will be available, containers will be available, Docker engine will be available, kubelet will be available, kube proxy will be available. So inside the Kubernetes worker node, we have pods and we have containers, we have Docker engine, we have kubelet, and we have kube proxy. Now, how to deploy our application in the Kubernetes cluster now? Kubernetes is a deployment software, right? Which is used to deploy our application, which is used to create the containers for our application, which is used to manage our containers. So we need to give some instruction to the Kubernetes to perform the operation. For example, I want to deploy my application in the 10 containers. I need to give the information to Kubernetes. For example, I want to delete my application from the Kubernetes. I want to undeploy my application. I want to increase the pods. I want to decrease the pods. I want to do the scaling. I want to scale up. I want to scale down. So that framework is available. Kubernetes is providing the framework to manage our application deployment, scale up, scale down, auto scaling, load balancing, self-healing. All these things we are getting. But we need to give some instruction to the Kubernetes to perform the deployment. To give the instruction to the Kubernetes, we need to communicate with the control plane. In order to communicate with the control plane, there are two ways available. By using web dashboard, you can communicate with the Kubernetes control plane by using kubectl, CLI command also. By using commands also, you can communicate with the Kubernetes. By using web dashboard, you can communicate with the Kubernetes, or by using kubectl also, you can communicate with the Kubernetes cluster. So these are the three important things that we need to understand before getting into Kubernetes architecture internals. Kubernetes works based on the cluster architecture. Cluster is nothing but group of servers. In the Kubernetes, control plane will be available and worker nodes will be available. Control plane is called as master node. Control plane is called as master node. And worker nodes will be available. Whatever the deployment we need to do, The instruction we will give to the control plane will give the instruction to the worker node. Inside the worker node, our application will be executed as a pod. How can we communicate with the Kubernetes cluster as a DevOps engineer or as a programmer? That's where you can use a web dashboard to communicate with the control plane, or you can use kubectl to communicate with the control plane. All right. Now we need to understand the internals of this Kubernetes cluster architecture. Okay. So first one is control plane, guys. So inside the control plane, we are having schedulers, right? Inside the control plane, we have API server, we have scheduler, we have controller manager, and we have etcd. So let's talk about Kubernetes architecture components. Let's talk about Kubernetes architecture components. All right. Kubernetes architecture components. What is the first component in the Kubernetes architecture? Control plane. Inside the control plane, API server is available. Sir, what is this API server? API server will take our request. Now, I want to deploy my application in the Kubernetes. By using web dashboard or by using kubectl, I will tell to Kubernetes, hey Kubernetes, deploy my Python application. So this is the Docker image of my Python application. Please deploy that application in the Kubernetes. Like this, as a programmer, as a DevOps engineer, I will send request to the control plane. When I send the request to the control plane, then inside the control plane, there is a component called API server. API server will receive incoming request and it will store that request information into etcd. Okay, if you see this architecture, API server is available and etcd is available. Whatever the request I'm sending by using kubectl to the Kubernetes cluster, that control plane, API server will take my request. Okay, whatever the request I sent, request nothing but deploy the application or increase the containers of the application, decrease the containers of the application, delete the application from the Kubernetes. These are called requests to the Kubernetes. So I will send a request to run my application in the cluster. When I send that request, then API server in the control plane will receive our request and will store our request into etcd. Okay, what is this etcd in the Kubernetes? etcd is the internal database for the Kubernetes cluster, which is used to store the request information. What request we have sent to the Kubernetes cluster, what request received by the API server, all the request information will be maintained in one database in the Kubernetes that is called etcd. etcd is Kubernetes cluster database, that is internal database for the cluster, which is used to maintain all the request information. Okay, I sent a request to deploy my Python application. API server received my request and it stored that request into etcd database. Once that is stored in the etcd database, then scheduler will come into picture. Scheduler is responsible to schedule the pending tasks available in the etcd. Whatever the request comes, that will go to API server. API server will store in the etcd. Then scheduler will come into picture. It will check what are the pending tasks available in the etcd. Then it will take those pending tasks and it will schedule the pending task to the worker nodes. Okay, I want to deploy my application. That task is still pending. So it is available in the etcd. So then scheduler comes into picture. Scheduler will check pending tasks in the etcd and it will schedule those tasks in the worker nodes. Okay. So this person asked you to deploy one Python application. Okay. So then scheduler will check the request is still pending in the etcd. Then scheduler will communicate with the worker nodes. Scheduler will check how many worker nodes are available, how many are up and running. So there are two worker nodes available, worker node 1 and worker node 2. Out of these two worker nodes, which worker node is free? Suppose simple. When client gave some requirement, manager will check which team member is available. Then manager will assign that task to the team member. Then team member will do the actual task. Manager will take the task from the higher authority or from the client. Manager will assign the task to the team members. Team members will complete the task. Same concept here also. When we send a request, control plane will take it, then it will assign to the worker node. Okay, so here the request will be received by API server, then it will store that request in the etcd, then scheduler comes into picture. Scheduler will check which worker node is available to do this task, then it will assign the task to that particular worker node. In that worker node, our application will be deployed as a pod. Worker node is nothing but a slave, master and slave. Control plane is called as master and worker node is called as a slave. Worker node is called as slave. Okay. Then what is kubectl? Can you guys tell me what is kubectl in the Kubernetes? A software to communicate with the Kubernetes cluster. A command line interface which is used to communicate with the Kubernetes cluster. Okay. What is API server? Come on. What is API server in the Kubernetes? It is going to receive the request in the control plane. Then what is etcd? What is etcd? etcd is a Kubernetes cluster database. Then what is the scheduler in the Kubernetes cluster? What is the scheduler in the Kubernetes cluster? It will check what all the pending tasks available and it will assign the pending tasks to the worker nodes. Okay, here guys, scheduler will get the available worker nodes information because inside this cluster, inside one team, multiple team members will be available. One manager, multiple team members will be available, right? So which team member is free? For which team member we need to assign this task? That will be taken care by scheduler. How scheduler will understand to which team member we need to assign this task. That's where here there is a concept called kubelet, guys. Can you see the concept here? Kubelet. Kubelet is called as personal assistant for the worker. Is called as a node agent. Scheduler will get the available worker nodes information by using a node agent which is called kubelet. API server will receive the request, will store in the etcd. etcd is a cluster database. Scheduler will check pending tasks in the etcd and will schedule those tasks in the worker nodes. How the scheduler will know in which worker node it has to schedule the task? Then scheduler will get the available worker nodes information by using kubelet. What is the kubelet in the worker node? Kubelet is like a PA, personal assistant. Okay. So PA, suppose if you take any celebrity or any politician, the personal assistant will be available for them. They will manage their schedules. Okay. Suppose if you want to connect with any celebrity, first you need to check the celebrity availability by talking to his PA. Then PA will tell the schedule, when he is available, at what time he will give the appointment for you, all that information. Same concept here. For every worker node, a agent will be available. That agent is called as kubelet. Kubelet is called as worker node agent. By communicating with the kubelet, we will understand the health of the worker node, status of the worker node, whether that worker node is available or not, what pods are running in the worker node. All that information we can get by using kubelet. So here, scheduler is going to communicate with the worker node using this kubelet. Then based on the availability, scheduler will assign the task to the worker node. Okay. Then, so here, scheduler should communicate with the worker node. Worker node should communicate with the control plane, should communicate with the worker node. Worker node should communicate with the control plane. Control plane is one machine. Worker nodes are other machines. So total 3 machines available here. Group of machines, that is called a cluster. So this control plane machine should communicate with the worker node machine. Worker node machine should communicate with the control plane machine. So there should be some network communication. There should be some network communication. So to establish this network communication, kube proxy will provide the network. Okay. Kube proxy provides the required network for the communication from control plane to worker node and worker node to the control plane. So that is called kube proxy. Okay. Kube proxy provides network for the cluster communication. So cluster communication means group of servers available. this group of servers should communicate. Suppose, for example, your manager is available in the Hyderabad location. You are working from the Bangalore location. How manager will connect with you? Through email or by using Teams chat. He will message you in the Teams chat, or he will set up a meeting with you. He will send an email to you. That is a team communication. Right? So there should be some software for the team's communication in the project. Similarly, for the cluster communication, network is required. That network will be provided by Kube proxy. Okay, kubelet is called as worker node agent. Kube proxy will provide the network which is required for our cluster communication. Are you able to understand what is a kubelet and what is a kube proxy? Are you able to understand what is a kubelet and what is a kube proxy? Kubelet is called as worker node agent, and kube proxy will provide the network for the cluster communication. Okay, then once the communication is done with the kube proxy, scheduler will schedule the task to the worker node. Scheduling the task nothing but application deployment. How the application will be deployed? In the Docker, directly container will be created. In the Kubernetes, container will not be created directly. In the Kubernetes, pod will be created. Sir, what is the full form of the pod? There is no full form for the pod, guys. What is the pod? Pod represents running instance of the application. In the Kubernetes, what is pod? Pod is called as smallest building block that we run in the Kubernetes cluster. Pod represents runtime instance of our application. If you are deploying your application in the Kubernetes, nothing but you are creating a pod. Inside the pod, our application will be deployed. Inside the pod, our application will be executed. Okay, etcd is a database. API server will take the request and will store in the etcd. Scheduler will check the pending tasks in the etcd and it will schedule those tasks in the worker nodes. Scheduler will get the worker nodes information by using kubelet. Kubelet is called as a node agent. And cluster communication is required. For that, kube proxy will provide the network. And once the scheduler scheduled the task in the worker node, pod will be created. What is the pod? Pod is very important thing in the Kubernetes. In the Kubernetes, everything will be represented as a pod only. Pod is the smallest building block that we can run in the Kubernetes cluster. So if you want to deploy your application, you need to create a pod. Pod means smallest building block that we run in the Kubernetes cluster. It represents running application. Pod means our application is running. Inside the pod, you can create multiple containers also. For one application, you can create multiple pods. So here in the Kubernetes, everything will be deployed as a pod. Pod is the smallest building block in the Kubernetes cluster. Inside the pod, our container will be executed. To create the container, Docker image we will use. To run the Docker image, Docker software is required. That's why in the worker nodes, Docker engine will be available, which is used to run the Docker image. When we run the Docker image, Docker container will be created. That a Docker container will be created inside the pod. Okay. Pod means smallest building block that we run in the Kubernetes cluster. It represents runtime instance of our application. If you want to deploy your application, then we need to create the pod. In Kubernetes, our project will be executed as a pod. Inside the pod, containers will be created. To create the container, Docker engine will be used. That is the reason inside the Kubernetes worker nodes, Docker is available. Inside the Kubernetes worker node, Docker is available. Are you able to follow me? What is pod? Pod is the smallest building block that we can run in the Kubernetes cluster. Pod is nothing but smallest building block that is a Kubernetes cluster that is used to run our application. It represents running instance of our application. Sir, I want to deploy my application in the Kubernetes. Then you need to create the pod. Inside the pod, your application will be executed. Okay, then whether pods are created or not, whether the pods are running or not, that the resources, whatever the resources that we have in the Kubernetes cluster, those resources are working as expected or not. Is there any problem for the resources? Is there any issue for the resources? That will be managed by controller manager. In the Kubernetes cluster control plane, controller manager is available. Controller manager will monitor all the Kubernetes resources functionality. What all the resources available, whether those resources are working as expected or not. Okay, the resources monitoring will be taken care by controller manager in the Kubernetes. That controller manager is belongs to control plane. For example, I want to run my application in one pod. Is that pod is running or not? Is that pod created or not? Will be monitored by controller manager. For example, my application is running in one pod. Now I want to run my application in the two pods. So I will tell to Kubernetes to increase one more pod. Whether that pod is increased or not, whether that pod is created or not, will be monitored by control plane in the Kubernetes. That pod is created or not, that pod is running as expected or not, will be monitored by control plane, controller manager. Perfect. Now, sir, how to set up this Kubernetes cluster? I want to go for the Kubernetes cluster set. Kubernetes cluster, we can set up in multiple ways, guys. Now I want to do the practicals on the Kubernetes. In order to do the practicals, we need to set up the Kubernetes cluster. Kubernetes cluster we can set up in multiple ways. One is self-managed cluster. Another one is provider-managed cluster. Self-managed cluster, nothing but you create your own cluster and you run your application. Suppose I want to take one computer. In that computer, I will install the Kubernetes software. Then I will set up my cluster. Then I will run my application. If you set up the cluster on your own, then that is called as self-managed cluster. For example, I don't want to set up the cluster on my own. I want one ready-made cluster. Then you can go for managed Kubernetes cluster. Managed Kubernetes cluster, nothing but cloud provider will give you ready-made Kubernetes cluster in order to run your application. Okay. So if you want ready-made cluster, then you can go for managed cluster. Managed cluster means somebody will manage our cluster, then we can use that to run our application. So here there are two things. One is self-managed cluster, another one is managed cluster. In the self-managed cluster also, again there are two types available. One is Minikube, another one is Kubedium. Minikube is nothing but single node cluster. Everything, whatever we have seen in the previous diagram, control plane, worker nodes, like this architecture will not be available. Everything will be available in one system only. Then it is called single node cluster. This is single node cluster only for your learning purpose, only for your practice purpose. In the real time, we don't use Minikube for running our applications, guys. Who will use Minikube? Anybody who is a fresher to the Kubernetes, who is starting the Kubernetes learning, first time they are working with the Kubernetes, they want to learn the Kubernetes concepts, then they will go for Minikube. Minikube is a single node cluster that is only for learning purpose. Kubernetes Minikube cluster only for learning purpose. Minikube is called as single node cluster. Okay, only one computer, everything, control plane, worker node, everything will be there in one system. That is called single node cluster. That is not recommended for the real time. In the real time, we need to go for multi-node cluster. Multi-node cluster, nothing but this is the architecture. Multiple machines. Instead of taking one machine, we are going to take multiple machines to run the Kubernetes. That is called multi-node cluster. This multi-node cluster you can set up on your own by using a software called Kubedium. Kubedium software is available. Sir, what I need to do with the Kubedium? You take 3 Linux machines, then you install all these softwares in one machine, then you install all these softwares in the other 2 machines. You take care of everything on your own. That is called Kubedium. You install all the required softwares to set up the cluster. That is called multi-node cluster, which you manage on your own. But if you go with the Kubedium, you need to manage the cluster. If a cluster is down, then your application will be down. Okay, risk is there when you go for the Kubedium cluster, guys. Okay, if your systems are crashed, then your applications will be down. That's why In the real time, people will go for managed cluster, AWS EKS cluster. EKS is a service in the AWS, which is nothing but Elastic Kubernetes service. So I want to run my applications with the help of Kubernetes. That Kubernetes cluster, I don't want to set up. I want one ready-made Kubernetes cluster. That's where AWS Cloud is giving EKS service. EKS is one of the most famous and powerful Kubernetes cluster service. If you want to run your applications in the Kubernetes, then go with the AWS EKS. AWS EKS will provide you ready-made platform, ready-made cluster for you. AWS will take care of your cluster. In the AWS, EKS available. In the Azure, AKS available. AKS nothing but Azure Kubernetes service. In the GCP cloud, GKE, Google Kubernetes Engine is available. IBM IKE is available. So these all are the managed clusters. Managed clusters nothing but those companies will take care of our cluster. Those companies will give the cluster for rent. Okay. Oracle OKE is available. IBM IKE is available. GCP GKE is available. Azure AKS available. AWS EKS is available. Okay. So in this workshop, I'm going to show you AWS EKS. I'm going to set up my cluster in the AWS by using EKS service in order to run our applications. So that is most famous cluster service in the market. In the real time, which cluster we will use? It depends on which cloud they are using for the project. If they are using AWS cloud, then definitely they will go with the EKS cluster. If any project is using Azure cloud, they will go with the AKS cluster. If they are using GCP cloud, they will go with the GKE cluster. Suppose in my company, cloud is not available, then they will go with the Kubernetes cluster. It depends on the company, it depends on the project. Okay. In my project, we are using EKS cluster. In my project, we are using EKS cluster, AWS EKS. EKS stands for Elastic Kubernetes Service. So we are going to set up a cluster like this in the AWS cloud by using EKS service. Sir, how to set up this cluster in the AWS? What are the prerequisites we need to have to set up the cluster in the AWS? And remember guys, whatever the EKS cluster we are going to set up in the AWS, that is not free. That is a paid service. Kubernetes is free. I'm telling once again, Kubernetes is free. But here, EKS is not free. AWS EKS is a paid service. Bill will be generated. Okay. So if you use that cluster for 24 hours, that's negligible. 100 rupees, something like that bill will be generated. But if you run the cluster for 1 month, then 3,000 to 4,000 rupees bill will be generated. Kubernetes is free. Sir, Kubernetes is free now. Then why we are going to get the bill? Here we are taking provider managed cluster. We are using AWS EKS cluster. We are not setting up the cluster. We are going to use a ready-made cluster. So to give that ready-made cluster, AWS will charge. That is also hourly charges will be available. If you set up EKS cluster, per hour bill will be generated. Okay. So I will show you how to set up the cluster. If you run the cluster for 24 hours, no problem. Very less amount only will be generated. That is negligible. And you no need to pay that bill to the AWS also. I will tell you how to make that bill amount also 0. But after your practice is completed, delete the cluster. Don't keep the cluster in the running state. If you keep the cluster in the running state, hourly bill will be generated. In this class, I will show you how to set up the cluster, how to do the practice, and how to delete the cluster also. We are going to use AWS EKS cluster. If you are using AWS EKS cluster, then Minikube and Kubernetes not required. Minikube is only for freshers, guys. That is only for the learning purpose. It is not used in the industry. Kubernetes means you need to do lot of setup to set up the Kubernetes cluster. That means you need to be strong in the Linux operating system. Then only you can set up the Kubernetes. you need to execute around 30 to 40 Linux commands to set up the KubeADM cluster. So if you are comfortable, if you are strong in the Linux operating system, then only you can set up the KubeADM. But in this workshop, there are people who are not from the Linux background. So I don't want to confuse them. That is the reason I am having KubeADM setup document also, but this is 2 days workshop. So that's why I don't want to waste the time. It will take 1 hour to set up the KubeADM cluster. And that too, if you know Linux, then only you will understand. Otherwise, you can't understand the KubeADM. So that is the reason in this workshop, I'm going to use ready-made cluster, which is AWS EKS cluster. How to set up that EKS cluster by using AWS? I have prepared a beautiful document also, guys. Step 1, create EKS host in the AWS. Step 2, create IAM role and attach to the EKS host. And step 3, create EKS cluster using EKS CTL. Then once the setup is completed, we will do the practice. Once our practice is completed, this is the final command which is used to delete the cluster. Okay, so I have prepared one document in the GitHub repository. By following this document, we are going to set up our EKS cluster in the AWS cloud. Let's get started. The first step, create EKS management host in the AWS. EKS management host nothing but I'm going to create one EC2 instance in the AWS cloud. In that EC2 instance, I'm going to install these softwares. kubectl software I will install, AWS CLI software I will install, and EKS CTL software I'm going to install. So the step 1, create one EC2 instance in the AWS cloud. Then install 3 softwares in that machine. One is kubectl, another one is AWS CLI, another one is EKS CTL. Okay, let me go to my AWS account. So currently I logged in into my AWS account. I'm in the Mumbai region. Okay, then go to EC2 and create one EC2 instance. The EC2 instance type I'm taking as Ubuntu Linux flavor I'm taking. That is a Linux distribution. Got it? Now go and launch instance. Go and launch instance. The instance name I'm giving as EKS host VM. The AMI I'm selecting as Ubuntu. Okay, you can select any version of the Ubuntu. I'm selecting Ubuntu Server 22. I'm selecting EC2 instance with AMI Ubuntu Server 22. I'm taking for that. Instance type T2 micro, that is fine because it is just to execute our commands. T2 micro instance I'm taking. Key pair, if you already have the key pair, then you can select it. If you don't have it, you can create a key pair. I'm taking a key pair name as EKS PEM file. Create key pair. One key pair will be created and it will be downloaded. It is downloaded into our system. Then next, security group SSH traffic will be allowed. Then click on launch instance. Perfect. So with this, my EC2 instance created with Ubuntu AMI. Then connect with this EC2 instance by using SSH client. You can connect with this machine by using git bash or by using mobiextrom or by using putty. I'm going to use git bash in order to connect with this EC2 instance. Now my instance is still pending. Let's wait till it comes to the running state. Now the EC2 instance is started. It is in the running state. Then click on connect option. Here SSH client option is available. Follow this process in order to connect with that machine. Okay, so that PEM file is downloaded. It is in the downloads folder. Now here EKS PEM is available. Let me open my git bash here. Git bash I'm going to use as SSH client. Now, so in this git bash, we need to execute the commands in order to connect with that. First one is chmod command. It is used to give only read permission for the PEM file. Chmod 400 with the PEM file name. Yes, that is completed. Then next one, let us use this SSH command, which is used to make a connection to the EC2 machine. Copy this example command, which is SSH connection we are making to the Linux machine. Then click on enter. It is asking, are you sure you want to connect? Yes, boss, I want to connect.
Yes. So with this, I'm able to connect with my EC2 instance successfully. With which user account I have connected? I connected with the Ubuntu account. I have launched one Ubuntu EC2 instance, right? I connected to this machine as a Ubuntu user by using git bash. Once you are able to connect with this machine, then we need to execute these commands. Launch machine completed, then install kubectl. Already we know what is kubectl, which is used to communicate with the Kubernetes control plane. So you need to copy this script and execute. Here there is icon for copy. Just click on this icon. The script will be copied. Go to your git bash, right click, paste and enter. So this script, this is Linux script which is going to install kubectl software in the Linux machine. So this kubectl software is used to connect with the Kubernetes cluster. Yes, with this, kubectl is installed with version 1.19.6, something like that. Then once the kubectl is installed, then second one, AWS CLI software we need to install. Let's copy this script also. Go to this git bash, right click, paste and execute. So with this, I'm installing AWS CLI software in the EC2 instance. Right. It is installing that software. Yep. AWS CLI is installed successfully. The version 2.15.44 version got installed. Then EKSCTL command we are installing here. So let us take this one, AWS EKSCTL script. Then go to the same Linux machine and execute this. Perfect. EKSCTL, which is used to create the cluster, guys. In order to create the EKS cluster, we are using EKSCTL. That is also installed. So with this, successfully we completed our first step. Then coming to the second step, in order to create the cluster by using this EC2 instance, for that EC2 instance, some permissions are required, guys. Those permissions we are going to provide by using IAM role in the AWS. By using IAM role, we are going to give that permission. Okay. So what permissions we need to give, I have given in the document. So let us see that a document, go to the IAM service in the AWS, create the role with the permissions and attach that IAM role with our EC2 instance. Step 2, create IAM role and attach to EKS management host. We need to create one IAM role and we need to attach that IAM role to our EC2 instance. Okay. So what are the permissions? IAM, VPC, EC2, CloudFormation, administrator. All these policies we will attach for the IAM role. Now go to our AWS account, search for IAM service. Go to IAM, Identity and Access Management. In the AWS cloud, to manage users, roles and policies, IAM service is available. Go to IAM, click on the roles. Already there are several roles available which are provided by the AWS. Now I will create our own role. Click on create role, AWS service, use case is EC2. I'm creating this role for the EC2 service. Click on next. Here, policies. What are the policies you want to attach for this role? So I have given the list of policies. One is IAM full access. So give IAM full access for this one. Go here, type IAM. You will get IAM full access. Select it. IAM full access. This is one policy I have selected. Then second one, VPC full access. Type VPC. Amazon VPC full access. Second policy also I have selected. Then third one, EC2 full access. EC2 full access. Then CloudFormation full access is required. There is a fourth permission, CloudFormation full access. AWS CloudFormation full access policy I have selected. And finally, I'm giving administrator access also. Fine. So with this total 5 policies we have selected for this role. Go to next. Then give the role name. I'm giving AWS EKS role. That's it. You can give any name for the role. Then click on create. You can check it. What all the policies you have selected. All the 5 policies we have selected. Finally, click on create role. With this one, IAM role is getting created. The role name I have given AWS EKS role. Fine. Once this role is created, then what is the next step that we need to follow? We need to attach that role to the EKS management host. Whatever the EC2 instance we have created, for that EC2 instance, we need to attach that role. How to do that role attachment, guys? Select the machine that you have created by using this checkbox. Then go to actions, then go to security, then modify IAM role. So select the machine that you have created, then go to actions, then go to security, then go to modify IAM role. Here, you select the role that we have created. The role we created, that is AWS EKS role. Just now we have created this role, select. Sir, why we are selecting this role? If you attach this role, then this EC2 machine will have the permission to create the cluster. Okay, click on update IAM role. So with this, our step 2 also completed. Right, then what is the third step, which is very important, guys? This is the final step, which is used to create the cluster in the AWS by using EKS. So create EKS cluster by using EKS CTL. EKS CTL software already we have installed in our EC2. Then we need to follow this syntax in order to create the cluster. So in which region you want to create the cluster, how many worker nodes you want for the cluster, okay? So I want to create a cluster in the Mumbai region. Mumbai region code is AP South 1. And for the node, I want to use T2 medium instances. AP South 1A, 1B zones I want to use for that. If you want to create the cluster in any other region, then you need to change your region code and you need to change your availability zones. For North Virginia also, I have given the syntax. For Mumbai also, I have given the syntax. So currently, I connected with the AWS by using Mumbai region. You see, I'm operating my cloud services from the Mumbai region. So I'm going to use the command which is used to create the cluster in the Mumbai region. Now, currently instance is running only one instance is running, that is my host machine. By using this machine, I want to create the cluster. Now go to AWS, search for the service called EKS, Elastic Kubernetes service. This is the most trusted way to start, run and scale Kubernetes. Go to EKS. When you go to the EKS, here you can observe what all the clusters available. Elastic Kubernetes service, Amazon EKS, fully managed Kubernetes control plane. Okay. So this Kubernetes cluster that we are creating by using EKS, it is fully managed by AWS only. Go to the clusters here and you see currently, is there any cluster is available in the EKS service, guys? Currently, we don't have any clusters. Now I want to create the cluster. In order to create the cluster, this is the command. If you want to create the cluster in the North Virginia, you can use this command. If you want to create the cluster in the Mumbai, then you can use this command. I want to create the cluster in the Mumbai. This is the syntax, guys. In which region you want to create the cluster, what type of worker nodes you want to use, how many minimum worker nodes you want, how many maximum worker nodes you want. But in this command, I'm not giving the count of the worker nodes. If I don't give the count of the worker nodes, by default, it will take 2 worker nodes. One control plane, 2 worker nodes will be created. And remember this point, cluster creation will take 5 to 10 minutes of time. We have to wait for that. After cluster created, we can check our cluster is running or not by using this kubectl get nodes command. Once we are able to see the nodes which are available in the cluster, that means our cluster is ready. Okay, but immediately it will not be ready, guys. It will take 5 to 10 minutes of time to create the cluster. Okay, let me take this command. I'm giving the cluster name Ashok IT cluster 4. You can give any name for that. The region I'm giving as AP South 1, nothing but Mumbai region. The machines I'm using T2 medium machines. The zones 1A, 1B availability zones I'm using. Take this command, copy this, then go here and execute. Sorry, I got disconnected from the machine. Let me connect back using SSH. Yes, I connected back to this machine, Ubuntu machine. Then paste this command, ekctl create cluster. Now the cluster creation process is started. Ashok IT cluster 4, EKS cluster creation started. Wait for the control plane to become ready. So by using this AWS EKS, my control plane is getting ready. So this Kubernetes cluster is deploying now. Now you go to AWS and you can check it. Okay. As of now, the clusters are not available. So it will now you see error loading the cluster. Now the cluster is started. support period unknown, Ashok IT cluster 4, the status is creating. You need to remember this version. So if you say that I'm using AWS EKS cluster, in the interview they will ask you what is Kubernetes version you are using. We are using Kubernetes version 1.29. Okay. Now the cluster creation started. This is a provider cluster, EKS provider cluster. The version 1.29, the status is creating. So inside this cluster, you can see what all the worker nodes available. Okay. So currently the nodes are not there. Still the cluster creation in progress. If you go to the compute node groups, how many worker nodes available in the cluster, you can check that. So currently the cluster is not ready. Once the cluster is ready, then we can see what all the nodes available, how many nodes available. So don't disturb this, guys. It will take time, 5 to 10 minutes of time it is going to take to create the cluster. We have to wait. Guys, successfully, I'm able to complete my cluster setup. Now you can see EKS cluster 4 in the Mumbai region is ready. My AWS cluster is created successfully. So how to verify my cluster is working as expected or not? So to verify whether our cluster is working as expected or not, we can use a command called kubectl get nodes command. So when I use kubectl get nodes command, now you can see that there are 2 worker nodes are ready and they are running from 2 minutes. The status is ready. So this my control plane is created. My control plane is created. For that control plane, there are 2 worker nodes associated already. So with this, my setup is ready. We are ready to deploy our applications in the Kubernetes cluster by using AWS EKS. Now, so once the cluster is ready, I want to deploy my application in the cluster. So let me go to Kubernetes architecture diagram so that it will be clear for us. Now, if you see in the Kubernetes architecture, we have control plane and we have worker nodes. Now I want to deploy my application by using this Kubernetes cluster. So to communicate with the Kubernetes cluster, we have installed kubectl. By using kubectl command, we can connect with the control plane and we can give the task to the control plane. Then control plane will assign the task to the worker node. Okay, so here already kubectl is available in the EC2 machine. I created one EC2 machine. By using this machine, we created the cluster. So when I execute kubectl get nodes command, it is displaying how many worker nodes available in the cluster. So currently here, there are 2 worker nodes available in the cluster. And let me check kubectl get to pods. How many pods are running in the cluster? Currently, there are no pods in the default namespace. So no application we have deployed. Currently, pods are not running in the cluster. Now, in order to deploy the application, we need to create the pod. Okay. Before going to understand the deployment part of the application, we need to know 2 concepts in the Kubernetes. Then only we can do the application deployment. First one, what is pod? The first concept that we need to learn in the Kubernetes, what is pod and how to create the pod. In the Kubernetes, guys, pod is a smallest building block that we can run in the Kubernetes cluster. If you want to deploy any application in the Kubernetes, for that application, you need to create a pod. There is no full form for the pod, guys. This is the name pod. Pod is a smallest building block that we can deploy in the Kubernetes cluster. So any application that you want to deploy in the Kubernetes cluster, for that you need to create the pod. Our application will be deployed in the Kubernetes cluster as a pod. Suppose if you want to deploy your application with multiple instances, then you need to create multiple pods for your application. For one application, we can create multiple pods also. Why we need to create multiple pods for one application? If you create multiple pods for one application, high availability will be there. If one pod is deleted also, if one pod crashed, if one pod is damaged, then no problem. Other pod will be available to execute our application. That is the reason in the real time, for every application, multiple pods will be created. Pod is a smallest building block that we can deploy in the Kubernetes cluster. Our application will be deployed in the Kubernetes cluster as a pod only. For one application, we can create multiple pod replicas for the high availability. And whenever you create a pod, for every pod, one IP address will be generated. For every pod, one IP address will be generated. in order to access. And here, if any pod is damaged or if any pod is crashed, then Kubernetes will replace that pod. That concept is called self-healing. That concept is called self-healing. Okay, guys. If Kubernetes pod is damaged, then it is going to replace the pod. Guys, are you clear with my point? What is the pod and why we need to go for the pod? Pod is the smallest building block that we can deploy in the Kubernetes cluster. Our application deployment will happen by using pod only. For one application, we can create multiple pod replicas for the high availability. For every pod, one IP address will be generated. If a pod is damaged or if a pod is crashed, then Kubernetes will replace that pod for the self-healing process. Okay, next one. Here, to create the pods, we are going to write manifest YML. I want to create the pod. To create the pod, we are going to use a YML file. That YML file are called as manifest YML file. Okay, within the YML, we will specify what pod we need to create, by using which Docker image you want to create the pod, how many containers you want to create in the pod, what is the pod label, all that information we are going to specify in the manifest YML. And another thing is, whenever you send a request to the control plane to create the pod, I will write one YML file. In that YML file, I will declare my pod manifest and I will execute that YML by using kubectl. Then control plane will take my request. Control plane will assign the task to the worker node. Inside the worker node, my pod will be created. When the pod is created in the worker node, we cannot access the pod directly, guys. Okay, so I will write one manifest YML. That manifest YML, I will execute by using kubectl. Then the pod will be created inside the worker node. So kubectl is used to communicate with the control plane. I will assign the task to control plane. Control plane will assign the task to worker node. Inside the worker node, our pod will be created. By default, pods are accessible only within the cluster. You can't access the pod outside. That means you can't access your application directly if you create only pod for that. Then what we need to do to expose the pod outside the cluster, we need to implement a concept called service concept. First, we need to create the pod. Once the pods are created, those pods we need to expose. Those pods we need to expose by using services concept. Are you guys able to follow me? First, we need to create the pod. By default, pods are accessible only within the cluster. If you want to access the pods outside the cluster, then we need to use service concept in the Kubernetes. Okay, are you guys clear with what is pod in the Kubernetes? Pod is a smallest building block that we can deploy in the Kubernetes cluster. So if you see in our application, we need to create the pods. So using kubectl, I will connect with the control plane. By using the kubectl, I will execute my YML. In that YML, I will specify the configuration to create the pod, which Docker image it has to use to create the pod, what is the name of the pod, what is the label of the pod, everything we are going to specify in the YML. That YML I will execute by using control plane. Then that control plane will assign the task to the worker node. There are two worker nodes available. So in any worker node, it can create the pod. So pod is the smallest building block that we can deploy in the cluster. So if you want to deploy your application deployment in the Kubernetes means creating the pod only. For one application, you can create multiple pods. What is the benefit of creating multiple pods? High availability will be available. Suppose I created 3 pods. One pod got deleted. No problem. Kubernetes will replace that pod with the another pod. Self-healing will be available for the pods. Okay. Then here for every application, multiple pods will be available. So whenever you create the pod, outside you cannot access the pod. So pods we can access only within the cluster. Sir, how can we access the application running in the pod in our system? Then whatever the pods are created, those pods we need to expose by using a service concept in the Kubernetes. So are you guys clear with what is pod? Are you guys clear with the concept of what is pod in the Kubernetes? Pod represents runtime instance of our application. Pod represents runtime instance of our application. If you want to deploy any application, then that will be deployed by using pods only. If you want to deploy any application, the application will be deployed by using pods only. Pod is a smallest building block that we can deploy in the Kubernetes cluster. How to expose the pods? In order to expose the pods, we are going to use a concept called service concept. Okay, what is a service in the Kubernetes? Kubernetes service is used to expose the pods. Whatever the pods we have, in order to expose the pods, we are using service concept. Okay, in the Kubernetes, there are three types of services available. In the Kubernetes, there are three types of services available. What are those three types of services? First one is called cluster IP. Okay, whatever the pods we have created in the worker node, those all the pods we can expose by using one IP address. For every pod, a separate IP will be available. But for all the pods, I want to give one single IP for the load balancing. So if you want to expose all the pods by using single IP, then you can use cluster IP. But cluster IP is used to map. Every pod will have its own IP. Every pod will have its own IP. But all the pods I want to access by using single IP address for the load balancing purpose. Then you can go for a cluster IP. If you use the cluster IP, the pods will be exposed only within the cluster, but not outside. Okay. Suppose, for example, when we are going to deploy the database in the Kubernetes cluster, then database, I don't want outside people to access my database. Then the database I will expose by using cluster IP. For database, I will create three pods. For three pods, I want to give the single IP address. But those database pods should be accessed only within the cluster, not outside the cluster. Then we can give cluster IP service. We can use cluster IP service to expose the database pods. For example, I'm deploying my application. I want to access my application outside of the cluster. Then there is a service type called node port. So node port is a service which is used to expose the pods which are running in the particular worker node. Now there are two worker nodes available. My pods are created in the both worker nodes. I want to create 4 pods for my application. 2 pods created in the first worker node, 2 pods created in the second worker node. So which worker node pods you want to access outside, that you can expose by using node port. Okay, so if you want to expose your pods for access, we need to use a service concept in the Kubernetes. So in the Kubernetes, there are 3 types of services available. One is called cluster IP, which is used to access the pods within the cluster only, within the cluster, not for outside the cluster. If you want to access the pods outside the cluster, then there is a service type called node port is available. When you go for node port, you can access the pods which are running in the particular worker node. Okay, but if you want to access the pods running in all the worker nodes in the load balancing mechanism, then the service type is available as a load balancer. My application is having 10 pods, 5 pods running in one worker node, remaining 5 pods running in another worker node. Okay, then if you want to access all the pods with the load balancing technique, then we need to expose those pods by using a concept called load balancer. These 3 are called as services in the Kubernetes. First, we need to create a pod, and those pods we are going to expose by using service concept. Kubernetes service is used to expose the pods. We have 3 types of services in the Kubernetes. One is the cluster IP, second one is node port, and the third one is load balancer. Are you guys clear? Are you guys clear with what is pod and what is the service? Are you guys clear with what is pod and what is the service? Pod is a smallest building block that is used to run our application. If you want to deploy your project in the Kubernetes, then you need to create the pod only. To create the pod, we will write the YML file. To create the pods, we are going to write the YML file. Okay, once the pod is created, IP will be generated. Can we access the pods outside the cluster? We cannot access the pods outside the cluster. We cannot access the pod outside the cluster. Then how to expose the pods to access outside of the cluster? By using service. Service is used to expose the pods. How many types of services available in the Kubernetes? How many types of services available in the Kubernetes, guys? There are 3 types of services available in the Kubernetes. What are those 3 types of services in the Kubernetes? One is cluster IP, second one is node port, third one is load balancer. What is the meaning of a cluster IP? Cluster IP is used to access the pods within the cluster. Okay, so if you are deploying the database in the Kubernetes, database pods we don't expose for outside people. Database pods we will access only within the application, within the cluster. So any database if you are deploying in the Kubernetes, database pods we will expose by using cluster IP within the cluster. Suppose if you are deploying the application pods we can expose by using node port and load balancer. What is the difference between node port and load balancer? Can you guys respond? What is the difference between node port and load balancer? Can you tell me the difference between node port and load balancer? What is the difference between node port and load balancer? Node port is used to access the pods belongs to particular worker node. Okay, node port is used to access the pods belongs to particular worker node. If you want to access the pods belongs to all the worker nodes, then which service? Load balancer service we are going to use. Are you clear with my point? Are you guys clear with my point? Are you guys clear with my point? Now, I want to create the Kubernetes manifest YML to create the pod and expose the pods by using service concept. So when you are going to write the Kubernetes manifest YML, we need to follow some syntax. Okay, guys? Kubernetes manifest YML syntax. Manifest YML, it will start with 3 hyphens, end with 3 dots. Okay, let me save these notes for time being. All right. Now, Kubernetes manifest YML I want to write. So what sections we need to write in the YML file? In this YML file, 4 sections will be available. One is called API version. Okay. Second one is kind. Third one is metadata. Fourth one is spec. These are the 4 sections we are going to keep in our manifest YML. So API version and kind, metadata, specification. So in the Kubernetes manifest YML, we need to write these 4 sections in order to create the pod, in order to create the service. Okay. Now, when I want to create the pod by using this manifest YML, what is the configuration we need to write in the YML? Observe carefully, guys. First time, it may be a little bit confusion for you, but if you practice, then you can understand how to write this manifest YML files. Okay, when you are going to write the manifest YML file, I'm going to write a manifest YML file to create the pod and the service. I want to create the pod and I want to expose the pod by using service concept in the Kubernetes. Okay, so to create the pod API version, I'm going to specify apps/v1. Sir, what API version we want to use? That we can identify in the official Kubernetes documentation. Okay, I want to deploy my application by using Kubernetes cluster. I want to create the pods and I want to expose the pods by using a service concept. API version apps/v1. Kind, what you want to do? I want to create one deployment in the Kubernetes. Kind is a deployment. API version apps/v1. Kind is a deployment. Kind deployment means I want to create one deployment in the Kubernetes. I want to deploy my application. Metadata. For this deployment, can you give some name? Yes, I'm giving some name for the deployment, which is Java Web Application Deployment. Okay, what deployment you are creating in the Kubernetes? For the deployment, you give some name by using metadata. Then coming to the spec, how many pods you want to create for this deployment? Replicas 2. I want to create 2 replicas. That means I want to create 2 pods. If you give 5, then 5 pods will be created for your application. Why we need to create multiple pods for our application, guys? What is the reason for creating multiple pods for our application? For a high availability. If any one pod is deleted, then remaining pods are going to allow the traffic. That means the load balancing will happen, load distribution will happen when you create multiple pods. To achieve high availability, we are going to create multiple pods. And what is your deployment strategy? So there are multiple strategies available. I'm using rolling update. I'm using a strategy called rolling update strategy for that. Then deployment strategy type is a rolling update. Deployment strategy is rolling update, right? So I want to create a pod, API version apps/v1, kind is a deployment, metadata, name is Java Web Application Deployment. Under the specification, we are giving 2 replicas, and the deployment strategy we are going to follow as rolling update strategy. Recreate, rolling update, canary. There are 3 strategies available. Currently, I'm using one strategy called rolling update. Then next one, here we are going to specify selector. That means labels we are going to give for the pod. So selector, match labels. What is your pod label? For the pod labels, I'm giving the label name as app Java Web. So this selector is going to represent pod label. That means which pod you want to deploy. Which pod you want to deploy, that we are specifying by using match label. My pod label name will be Java Web App. Once it is completed, then we need to create the pod template. As of now, we have taken deployment manifest. Now, pod template we need to specify. In the pod template, we are going to specify metadata. What is the metadata? The pod name. You can give any name for the pod. I'm giving the name as Java Web Application Pod. I'm going to deploy one Java Web Application by using pod. So the pod name I am giving as Java Web Application Pod. And for the pod, I'm giving labels. The label name is Java Web App. And remember, whatever the label name you are giving for the pod, same label name we are going to specify as a selector. Kubernetes deployment should create the pods and should follow the deployment strategy. So this is the pod template. For this pod template, I'm giving a label name. This label name we need to configure as a selector. Then once the label is configured, then specification for the pod. Okay. So what is your pod specification? That means where is your Docker image to create this pod? So the Docker image information will specify by using specification. So inside the pod, what container you want to create? Inside the specification, I'm specifying my containers information, container name. I'm giving the name as Java Web Application Container. To create this container, I need to give the Docker image. My Docker image is available in the Docker Hub. The Docker image name is Ashok/Java Web App. So this is my Docker image for the application. Already this Docker image is available in my Docker Hub account. So by using this Docker image, this container will be created inside the pod, and for that pod, 2 replicas will be created. And this container is going to run on the port number. Ports will be available. The ports, container port. This is a Java application which will run on the Tomcat server with the port number 8080. With the port number 8080. This is a manifest YML which is used to create the pods for my application. Okay, so there are mainly 4 sections available. API version, kind, metadata, and spec is available. API version is apps/v1 and I want to create a deployment. For this deployment, I'm giving some name as a Java web application deployment. How many pods you want to create? I want to create 2 pods. So 2 replicas I want to create. Strategy, I want to go for rolling update strategy. And which pods you want to expose by using this deployment? Here pod template is available. In the pod template, I'm giving the name for the pod template, pod name and pod label. Labels and selectors are very important. Label is nothing but the ID for the pod. Label is used to identify the pod. This pod label is app Java web app. You can give any name for the label. Label is like an ID card. So with this label, it will identify that by using selector. And inside the pod, what container you want to create? I want to create Java web application container inside the pod. This is the name for the container and this is the image for the container. And ports, container port I am giving as 88. So this is called as our pod manifest YML. This is called as our pod manifest YML. By using this pod, we are deploying our application. Okay. So now, if you create this, can you access this application outside? Can we access these pods outside the cluster, guys? If you create the pod now. If you create the pod now, can we access these pods outside the cluster? Or we cannot access the pods outside the cluster. Can we create these pods outside the cluster? Can we access these pods outside the cluster? We cannot access the pods outside the cluster. We cannot access the pods outside the cluster. So what I need to do to access these pods outside the cluster? What I need to do to access the pods outside the cluster? We need to expose by using service concept. So what services available in the Kubernetes? Cluster IP, node port, cluster IP, node port, and cluster IP, node port, and load balancer is available. Cluster IP means within the cluster only we can access. Node port means particular worker node IP we will use to access the pods. Load balancer, which will give you the access for all the pods available in all the worker nodes by using load balancing technique. Now, so we need to expose the pods. We need to expose the pods. To expose the pods, we need to create the service. To expose the pods, we need to create the service concept. Are you getting my point? In order to expose the pods, we need to create the service concept. So for the service, again, manifest we have to write. So API version, service manifest you can write separately or you can write in the same also. Kind, metadata, and spec will be available. 4 sections will be available. So this is our deployment manifest to deploy the application by using pod. And these pods we need to expose. For that, we are going to write the service. API version, kind, metadata, and spec. API version, we are going to give this as V1 for the service. Kind. Kind represents what you want to create. What you want to create by using kind section service. What we want to create is that the service that we need to specify. And metadata. What is the name you want to give for the service? I want to give the name as Java Web App Service. I want to give the name as Java Web App Service. Okay, guys. Then next one, spec. Spec means specification of the service. What is the service type? I want to specify the service type as load balancer. I want to expose these pods by using a service called load balancer service. Okay, so when you specify type as a load balancer, then the pods will be exposed as load balancer service. Which pods you want to expose by using load balancer? Selector. Selector will represent pod label. The pod label is Java web application. This is the label. So these are the pods. This is pod template. This is used to represent our pod template. So I want to create a container inside the pod by using this Docker image. For this pod, I am giving the label as app::Java web app. Okay, so these pods I am exposing by using a service called load balancer type. So this service should identify which pods it has to expose. That's why the pod label we are configuring as a service selector. Pod label we are configuring as a service selector. Then after this one, port mapping. So our application will be running on the port number 8080. I want to map this to the port number 80. The container is running on the port number 8080 and load balancer port I want to map to 80. This is port mapping, which is used to access our ports by using load balancer service. Okay, so this is our manifest YML, guys. This is our manifest YML. This is used to create the pod. I want to create the two pods for the application, and the pods having the label. This pods should be created by using which Docker image. The Docker image name also I am specifying here. Once these pods are created, the pod label is available. By using this pod label, we are exposing the pods by using load balancer service. Writing this manifest YML requires a lot of practice. So this is a workshop. So I'm not focusing on butifying this YML file for you now, guys. So I will show you how to create the deployment, how to expose the pods, how to access the pods. In the Kubernetes class, as I told you, Kubernetes course will take 2 weeks of time, right? In that 2 weeks of time, you are going to learn this concept only. How to write the pod manifest YMLs, how to create the services by using YML, how to create the namespaces by using YML, how to create blue-green deployment by using YML. The 2 weeks of time I told you for the Kubernetes course, right? In the 2 weeks of time, we are going to learn this YML. As it is a workshop, I can't spend that much amount of time here to deal with all these things. Okay, so I will give you this YML file in order to create the deployment. After this workshop, you need to focus on how to write these YML files. Okay, it requires some practice, guys. Within 1 hour, within 2 hours, you can't understand these YMLs. So it may take 1 week to 10 days of time to understand how to write these YMLs. So Kubernetes course means they will tell you how to write these YMLs. Now, once this YML file is available, then you can go and create the deployment and you can access them by using this manifest YML. Okay, so look at this YML. Just read that YML from top to bottom once. Look at the YML from top to bottom once. Just for our understanding purpose. Strategy rolling update, recreate option will be available. Rolling update means when you are redeploying the application, it will create the old pods and it will delete the old pods and it will create the new pods. That is rolling update. There are 3 strategies available in the deployment: rolling update, recreate, and canary. Rolling update is available, recreate strategy is available, and canary strategy is available. Indentation is very important. You need to follow the indentation. This is a YML, or we can say YAML. Indentation is very, very important when you are writing these YMLs. You need to follow the indentation. So this first section will represent a deployment for the pod. Second section will represent a service for the pod. Now, whatever the YML file we have, that YML file we need to create in our machine. Okay, let me connect with this machine. Now, in this machine, we will create this YML. In this machine, we'll create the YML ls-l. So currently there is no YML file available. I'm going to create the YML to deploy my application. Deployment.yml. So vi java web app deployment.yml. This is called our Kubernetes manifest YML. I'm keeping our manifest YML here. So this is deployment section and this is my service section. Both are available in this YML, and the service type I'm using as load balancer. So I'm going to specify replicas to 2. So 2 pods will be created. Those 2 pods we are going to expose by using load balancer service. All right. So with this, my YML file is ready. Once the YML file is ready, then we need to create the pods. Okay. How we will create the pods now. We need to execute kubectl commands. So observe carefully, my YML file is ready. So now, before going to see this execution, can you see, is there any load balancer available in the EC2? We have used service type as a load balancer. Is there any load balancer created in my AWS account? Currently, load balancer is available. Currently, load balancer is not available. Currently, no load balancers available. When you execute this YML, we have created service type as a load balancer. So it is going to create one load balancer. It is going to create one load balancer to access our pods. Let me execute first. kubectl get pods. Any pods available? No pods available. kubectl get service. Any services available? No services available. One service, that is the default Kubernetes service available. Our application service is available, or our application service is not available. For our application, one service is available or not available? No. Currently, no pods available. Currently, no services also available. And any deployment is available. Any deployment is created. Kubernetes get deployment. Now, before executing my YML, I'm checking what are the pods available, what are the services available, what are the deployments available. So here, currently no pods available, no services available, no deployments available. Now, I want to execute this YML file. So before executing this YML, I'm using a command called kubectl get pods command. What is the purpose of get pods? To see what all the pods available in the cluster. Now, I want to see what all the services available. kubectl get service. This is going to display what services you have created in the Kubernetes cluster. If you want to see what deployments you have created in the Kubernetes cluster, we will use kubectl get deployment. I have executed 3 commands. I'm not able to see any pod. I'm not able to see any service. I'm not able to see any deployment. Okay. Now, so what is this command purpose? kubectl get pods command. This is used to check the pods which are running. What is the purpose of get service? It is used to check services running. Check services running. And kubectl get deployment. Check deployments created. Check deployments created. Check services created. Check pods running. Okay. If you want to see what all the pods running in the Kubernetes, then you can use kubectl get pods command. What is a kubectl? kubectl is a command line utility which is used to communicate with the Kubernetes cluster and check what all the pods running. kubectl get service. It is used to check what all the services created. kubectl get deployment. What deployment is created, I want to check that. Okay. Suppose if you want to see the pods running in the which worker node. Okay, check pods running in, check pods running in which worker node. So 2 pods. So these 2 pods created in first worker node or in the second worker node. I want to check the pods running in which worker node. For that, kubectl get pods -o wide. If you use -o wide, then that will display your pods are running in which worker node. Okay, so 2 pods I have given, right? Those 2 pods are running in the first worker node. Those 2 pods are running in the second worker node. We can check that by using -o wide option. Then how to create the deployment? How to execute the YML? In order to execute the YML, okay, execute Kubernetes manifest YML. Execute Kubernetes manifest YML. To do that, we will use a command called kubectl apply -f our YML file. Okay, kubectl apply command we are using to execute that YML. kubectl apply -f YML. So with this, that YML file will be executed. So in this YML, what we have given? We have given a deployment, we have given pod template, and we have given service. So pods will be created, deployment will be created, service will be created. Service type we have given as a load balancer. So as the service type is a load balancer, in the AWS, one load balancer will be created. We are using AWS EKS cluster. So when you use service type as a load balancer, the load balancer will be created in the AWS. Using that load balancer URL, we can access our application. Okay, so look at the commands that we are going to execute. kubectl get pods. What is the purpose of kubectl get pods command? kubectl get pods command will show you what all the pods running in the cluster. kubectl get pods -o void, which is used to display the pods running in which worker node. kubectl get service, which service you created to expose the pods, we can check it. kubectl get deployment. So you need to deploy your application by creating the pods. What is the deployment that you can see? How to execute this Kubernetes YML? In order to execute this Kubernetes YML, kubectl apply -f YML file. Okay. So if you use kubectl apply -f YML, then the YML file will be executed. In that YML, whatever the resources you configure, those resources will be created in the Kubernetes cluster. Are you guys clear with the commands now? Can we execute this and can we see our application is deploying in the Kubernetes or not? Yeah. My YML file is already available in this machine. Now, let me go and execute it. Okay. I got disconnected from the machine, connect back. I connected back to my machine. In this machine, I have the cluster access. By using this machine, kubectl command, I can communicate with my Kubernetes cluster, guys. Okay. So in this machine, kubectl is available. Using that kubectl, I can communicate with my Kubernetes cluster. Now, I connected to my EC2 machine. In that machine, my kubectl is available. Using the kubectl, I will communicate with the control plane. Control plane will communicate with the worker node. Control plane is going to communicate with the worker node. Inside the worker node, pods will be created. In which worker node pod will be created, that will be decided by the control plane. In which worker node pod will be created, that will be decided by the worker node. And those pods we are exposing by using service. All right. Good. Now check the pods again. kubectl get pods not available. Then check again. kubectl get service. Application service is not available. kubectl get deployment. kubectl get deployment. Deployment is also not available. Okay. No pods, no services, no deployments. Now I need to execute my YML. So my YML file is already available in this machine. Java web app deployment.yml. We need to apply this YML. How to apply this YML? kubectl apply -f file name. File name can be anything. There is no naming convention for the file. So my file name is Java web app deployment.yml. kubectl apply -f this web app deployment.yml. Now you can see the YML file is executed successfully. My deployment is created. My service also created. The application deployment is created and application service also created. Nothing but my pods are created. My pods are exposed by using service. So when we are writing this YML, we should be careful. The spacing, the indent spacing is also very, very important. If you do a small mistake with the space also, the deployment will not be created. So we have written the perfect YML and we are able to execute that YML by using kubectl apply command. My deployment is created. My service is also created. Okay. Then how to check it? Is it really created or not? Now go for kubectl get pods. Now you can see there are 2 pods created and those 2 pods are in the running status now. kubectl get pods. So 2 pods created. This is the name of the first pod and this is the name of the second pod. They are in the ready state and they are in the running. From 48 seconds, those pods are running. So with this, we are able to see the pods status. kubectl get pods, 2 pods are running. In which worker node those pods are created? -o void. Okay. Now it will display the pods are running. See, this is the pod IP and where these pods are running, you can see the node IP also. So in which worker node those pods are running, node IP is also printed. So this is running in the 192.168.21.176, and this is running in 192.168.117. So that means two pods are running in two different worker nodes. So I have given pod count as two pods created in two different worker nodes. How we are able to see the pods are running? This is pod IP. This is pod IP. This is pod IP. Two pods are running. Node IP. This is the first pod node in which worker node it is running. This is the second pod node IP in which worker node. So this is running in 176 node IP. This is running in 117 node IP. You can go to our EC2 dashboard and you can see the instances. There are two worker nodes are running. Select this worker node. Node IP is available. Okay, and this is the second worker node IP is available. 176 IP is available and 117 IP is available. One pod is running in 117 IP and the second pod is running in 176 IP. So two pods are running in two different worker nodes. Who created those pods in the worker nodes? I have created, or my control plane will decide that? I have created, or my control plane will decide that? I have given the task to control plane. Control plane has assigned the task to worker node. Those pods are created in the worker nodes. I have given pod count as 2. So 2 pods are created in 2 worker nodes. And check the service here, whether the Kubernetes service is created or not. kubectl get service command. kubectl get service. Yes, one service is available. That is the Java web application service is available. Service type is a load balancer. This is the load balancer URL in order to access our application. Now go to AWS load balancer section. Earlier 0 load balancers available. Now you see one load balancer is created in the AWS. Now refresh the load balancer section. One load balancer is created. Then click on this load balancer. For the load balancer, DNS will be available. This is the DNS name of the load balancer. By using this DNS name, we can access our application. Okay, hit this URL, the application load balancer is created. Okay, now you can check the deployment also. kubectl get a deployment. What is the deployment created? How many pods created in the deployment? So deployment is created. I told to create the 2 pods in the deployment, 2 replicas created, and they are available and they are up to date, they are running. My deployment is ready. Now, if you want to undeploy the application, you need to delete the deployment. If you delete the deployment, your pods will be deleted. Your services also going to be, your pods will be deleted basically. Right. So 2 pods are running on the deployment. These 2 pods are running in the each worker node. Now, how to access our application? Load balancer service is available. Take this load balancer DNS, go to the browser. My application context path is java-web-app. So with this, I'm trying to access my application, which is running in the Kubernetes cluster. Right, perfect. I'm able to access my application. So let me give this URL. You can hit this URL. Then you can see my application, which is running in the Kubernetes cluster. I have deployed my application. I have created the pods. Those pods I have exposed by using load balancer service. By using that load balancer URL, I'm able to access my project. Any application you can deploy. The only difference, guys, if you want to deploy any other application, the only difference, the image name is going to be different. Okay. So now I am using this Ashok IT/Java web app image that we have deployed. If you want to deploy another application, then you need to change the image. Where is the Tomcat? Where is the code? Everything is part of this Docker image. In the Docker image, our code plus dependencies plus servers, everything will be available in the Docker image. We are taking the Docker image and we are creating the deployment. That's it. Sir, where is Tomcat? Where is Java? Where is code? Everything will be available in the Docker image. So that's why if you know the Docker, then easily you can understand the Kubernetes. Docker is prerequisite to understand the Kubernetes. Fine. Now we are able to create the deployment in the Kubernetes. So we have created several resources in the Kubernetes deployment now. So what all the resources that you have created? If you want to get all those details, then you can use a command called kubectl get all command. kubectl get all command will be available. That will give you all the resources that we have created by using Kubernetes. All the resources that you have created by using Kubernetes, you can get this information. kubectl get all. We have created 2 pods. We have created 1 service. We have created 1 deployment. Okay. If you want to delete all these things, then you need to use a command called kubectl delete all -all. Then everything will be deleted. Can we see one of the concept called self-healing? As I told you, Kubernetes will provide you self-healing. What is the meaning of Kubernetes self-healing? If any one pod is deleted, Kubernetes will recreate that. Can we check it? Can we prove that practically? Is Kubernetes providing self-healing or not? There are 2 pods running. I will delete 1 pod and I will see the behavior of the Kubernetes. I will delete 1 pod and I will see the behavior of the Kubernetes. Okay. Now observe. You can see the count kubectl get pods. There are 2 pods running. Now these 2 pods, you can see age of the pods from the last 15 minutes. These 2 pods are running. kubectl get pods command from the last 15 minutes. These 2 pods are running. Now what I want to do is delete it. kubectl delete 1 pod. I'm giving pod IP. kubectl delete pod with the pod name. kubectl delete pod with the pod name. Now pod is deleted. So now you see, earlier there are 2 pods available. Those 2 pods are running from the 15 minutes. Now I have deleted 1 pod by using kubectl delete pod name. Now check the pods count. Get pods. Again 2 pods are available. So 1 pod is running from 16 minutes. Another pod is running from 18 seconds. That means Kubernetes recreated the pod. Is a self-healing available? Is a self-healing available in the Kubernetes or not? If any one pod is deleted, another pod is created. High availability. So I have given the ReplicaSets too. So always 2 pods will be maintained. If 1 pod is deleted, then it is creating another pod that is called self-healing. Kubernetes is having self-healing. Are you able to prove that Kubernetes is having self-healing? If both pods deleted, and then again 2 pods will be created. If both pods are deleted, another 2 pods will be created. Okay. It no need to identify which pod is deleted. If 1 pod is deleted, another pod will be created. That's it. If 1 pod is deleted, then another pod will be created. That is called self-healing. Self-healing, nothing but if any 1 pod is deleted, then it will create the another pod for that. Now let me do that once again. Let me check the kubectl get pods command. Yeah, 1 pod is running from 17 minutes. Another pod is running from 97 seconds. Let me delete the old pod. How to delete it? kubectl delete pod name. Select it. If you select it, it will be copied. Then paste it. Delete that pod also. Old pod, which is running from 17 minutes, I have deleted. Then check the pods immediately. Another pod came. 5 seconds ago, 1 more pod got created. So if you delete 1 pod, Kubernetes is creating another pod. That is called self-healing. This is one of the biggest advantages in the Kubernetes. High availability will be there for our application. Now, I want to check the logs of the pod. kubectl logs give the pod name. Then you can paste it. kubectl logs of the pod. It will display how your application is executing. Your pod logs will be printed. If any pod is damaged, if any pod is crashed, if any problem occurred in the pod, how can we check the logs of the pod? By using kubectl logs command, you can check the logs of the pod. In the interview, they will ask this question also. My pod is having some problem. How do you troubleshoot that problem? By checking the logs of the pod. How to check the logs of the pod? To check the logs of the pod, we will use kubectl logs command with the pod name. So this is the pod log, it is going to display how our application is started. This is my Spring Boot application. This Spring Boot application is running in the Tomcat server with the port number 8080. So internally, it is using Tomcat server to run our application. That Tomcat server running on the port number 8080, that 8080 port number is called as our container port number. Whatever the 8080 port is available, that 8080 port is called as our container port number. Are you guys clear with my point? Okay. Now, next, I want to do the deletion. I want to delete everything which I have created. To delete everything which we have created, kubectl delete all all the resources will be deleted. My pods are deleted, my services are deleted, my deployment also getting deleted. If you want to clean up the cluster, then you can use this command kubectl delete all all. What are the resources that we have created in the cluster? If you want to delete all these resources, then you can use kubectl delete all all. So whatever the deployment is created, the deployment got deleted. Whatever the deployment is created, the deployment got deleted. Are you clear with my point? Are you clear with my point? Okay. Now, whatever the deployment that we are doing manually, we are executing kubectl command manually. But in the real time, the deployment will be created by using a CI/CD pipeline like this. Okay. We are going to create one CI/CD pipeline by using Jenkins. So when we run this Jenkins pipeline, then what will happen? Jenkins will take the code from the Git repository. Jenkins will build that code by using Maven. Jenkins will create a Docker image for the application. Then finally, that Docker image will be deployed in the Kubernetes cluster. This is our Jenkins CI/CD pipeline. Developers will be available for the project. Developers will write the code and they will push that code to the Git repository. Then the Jenkins pipeline will trigger. The Jenkins pipeline will take the code from the Git repository. Then Jenkins will build the code by communicating with the Maven. Code compilation, code packaging will happen by using Maven. Once the code is packaged as a jar file or war file, then Jenkins will communicate with the Docker. It will create the Docker image for the application. That Docker image we are going to configure in our Kubernetes manifest file. This is the Docker image. Once the Docker image is created, then Kubernetes deployment will happen by using that Docker image. This is called CI/CD pipeline. So in the real time, the project deployment will happen with this CI/CD pipeline. Docker image creation, Kubernetes deployment will happen. Okay, guys. Here, so if you know this is Jenkins, Docker, and Kubernetes, then you can build this CI/CD pipelines. So in the real time, DevOps engineers are responsible to create this CI/CD pipeline. DevOps engineers are responsible to build these Docker images. DevOps engineers are responsible to create the Kubernetes manifest file and create the deployment of the application. As a developer, you should also have some idea what is the CI/CD pipeline, how Kubernetes deployment will happen, how to check the logs in the Kubernetes, how to check the pods in the Kubernetes, what is the Kubernetes manifest YML, what is pod, what is service, how many types of services available. This idea should be there for the developers also. Nowadays, for the developers also, they are asking the questions related to DevOps tools. How to create CI/CD pipeline by using Jenkins, how to build a Docker image by using this Docker, how to deploy the Docker image by using Kubernetes, what is Kubernetes cluster, everything.